Sup, dogs? Welcome back to the Majesty of Reason. I'm Joe Schmid, and today we are going in depth on the Hilbert's Hotel argument. I'm going to be giving you guys the most in depth analysis of the Hilbert's Hotel argument in existence, in video form at least. So, yeah, get pumped. All right, so before getting into the video, we have a fun fact. First, this document is available for patrons. And secondly, see the reference document in the description. I'm going to have lots of different references throughout this document because I did boatloads of scholarly research for this. So you guys can check out the reference document in the description for access to those scholarly resources, in case you want to dig into things further.
And by the way, I'm going to do a giveaway in honor of this episode. So this is a sticker. It can go on your laptop. It can go on your phone case. It can go on in your dorm room. It can go wherever. But it's a pretty fun sticker. It says, "Welcome to the Grand Hilbert Hotel. No vacancy, but we can move some people around." So yeah, so I'm going to be giving away 5 of these to the first 5 people who become patrons at $3 or more per month. So yeah, like I said, the first 5 people who sign up, I'm going to send this to you. And I'm also going to send like a personal note thanking you guys for watching my channel and for becoming patrons. So yeah, I'll send that to you. And anyway, that's what it looks like on a laptop. It's about 4 inches wide and it's about a little over 2 inches tall. So it's a recent addition to my laptop. And I was like, hey, why not do a giveaway? So yeah, check that out. The link is in the description to the Patreon. It's just patreon.com/majesty of reason. All right, on to the video.
So the Kalam cosmological argument has 2 stages. Stage 1 aims to infer at least one first cause of the universe, whereas stage 2 aims to identify that cause with God. Also, the Kalam comes in different forms, most notably the Old Kalam and New Kalam. The New Kalam, unlike the Old Kalam, crucially relies on causal finitism, which is the view that infinite causal regresses are impossible. And for more on this terminology, see the first episode in my Kalam series with Stephen Woodford, or Rationality Rules. That is in my Kalam playlist, which, of course, I highly recommend you to check out. A substance has properties, that is to say. So here's the Old Kalam, which I'll hereafter refer to as the Kalam. Premise 1, whatever begins to exist has a cause. Premise 2, the universe began to exist. Conclusion 3, so the universe has a cause. Now, in this video, like I said, we're going to deep dive into a prominent defense of premise 2 of this argument based on Hilbert's infinitely capacious hotel. It's going to be the most comprehensive guide to the Hilbert's hotel argument in existence, so buckle up. So on to the Hilbert's hotel argument itself. So before laying out the argument, we need some background. Now, this is going to be just a little bit technical, but trust me, I can explain this in a way that you can understand, or at least I hope I can, so let's get to it. So first up is some set theoretic background. So what is a set? A set is a collection of definite and distinct things. The things within a set are called the members, or the elements of the set. So for instance, you can have a set of my computer, you, my left toe, and the Eiffel Tower, right? That's a set, and it has various different members or elements that I just specified. Set A is a subset of a set B, just in case every element of A is also an element of B. Furthermore, a set A is a proper subset of a set B, just in case A is a subset of B, but A is not identical to B. And so what that's saying is basically, if A is a proper subset of B, then every element of A is in B, but there's at least one element of B which is not in A. Okay, so that's sets and subsets, as well as proper subsets. What about the size of a set? Well, the size of a set, that is the set's number of elements, or how many members it has, is called that set's cardinality. For instance, the cardinality of the set containing 10, 11, and 12 is 3, since it has 3 elements. Pretty simple, right? 2 sets have the same cardinality, just in case they can be put in a one-to-one correspondence with one another. And that's just a fancy way of saying that each element of the first set can be paired with exactly one element of the second set, while each element of the second set can be paired with exactly one element of the first set. So for instance, the set 10, 11, and 12 can be put in a one-to-one correspondence with a set of 1, 2, and 3, right? You can pair them one-to-one. There's a kind of one-to-one mapping or correspondence between them. So that's the size of a set. An infinite set, so that's also pretty important in this context, before we get into Hilbert's Hotel, an infinite set is just a set with infinitely many members. For our purposes, we'll be focusing only on infinite sets whose cardinality is the same as the set of natural numbers. That is, the set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, etc., right? Now, some definitions, mind you, begin the natural numbers with 1 and others with 0. Okay, so there's actually different ways to define natural numbers. Just for simplicity, I'm just going to go with the positive integers. Now, the cardinality of this kind of infinite set is Aleph null, and that's a little Aleph. Some people pronounce it Aleph, but I don't like that, so I'm going with Aleph. And then the little subscript 0. Sometimes because I was lazy, I didn't put it as a subscript, but yeah, it's Aleph null, or Aleph null, or Aleph naught, or Aleph naught. etc. Aleph null is the first or smallest infinite cardinal number. So you actually can have larger, and we do have larger infinite cardinal numbers. You have Aleph 1, Aleph 2, Aleph 3, Aleph 4, and so on ad infinitum, indeed. Now, importantly, this kind of infinite set has Cantor's property. Georg Cantor was a German mathematician. A set has Cantor's property when it can be placed in a one-to-one correspondence with infinitely many of its proper parts or its proper subsets. And what that means is that the whole set has the same cardinality, that is, the same size or number of elements as those proper subsets or proper parts. For instance, there are just as many natural numbers as there are even numbers, despite the fact that the even numbers are a proper subset of the natural numbers. To say that the even numbers are a proper subset of the natural numbers is to say that every member of the set of even numbers is a member of the set of natural numbers, but there are members of the set of natural numbers that aren't members of the set of even numbers, right? And again, to say that there's a one-to-one correspondence between these sets is to say that you can basically map each member of each set to one another such that there's really no members left out, no members left behind. So you compare 2 with 1, 4 with 2, 6 with 3, 8 with 4, 10 with 5, and so on ad infinitum, right? Any set with the same cardinality as the set of natural numbers, that is the cardinality Aleph null, has Cantor's property. So yeah, that's Cantor's property. Cantor's property, again, is just when a set can be placed in one-to-one correspondence with infinitely many indeed, of its proper subsets. And Cantor's property is the mark of being a set with a cardinality Aleph null. It's an infinite set, an actually infinite set. Okay, that's the background on set theory. We have to go through this, I'm sorry, but it's important for understanding what we're going to be going through later on. So now let's get some background on infinity. Okay, so the final distinction we need to cover is that between an actual infinite and a potential infinite. Here's how Craig puts the distinction. The crucial difference between an infinite set, that is an actual infinite, and an indefinite collection, that is a potential infinite, would be that the former is conceived as a determinate whole actually possessing an infinite number of members, while the latter never actually attains infinity, though it increases limitlessly. As Craig says elsewhere, an actual infinite is a collection of definite and discrete members whose number is greater than any natural number, 0, 1, 2, 3, and so on. Thus, an actual infinite is a collection of distinct elements whose number is greater than any natural number, and consequently whose members can be placed in one-to-one correspondence with the natural numbers. By contrast, a potential infinite is, strictly speaking, not infinite at all. It's a quantity that 1 is increasing, 2 has no finite limit, and 3 is always finite. A potential infinite is thus a collection whose number is always finite, but it's always increasing without bound. So to put things as clearly as possible, an actual infinite is a collection with infinitely many members, that is, Aleph null many members, whereas a potential infinite is a continually, limitlessly growing collection that always has finitely many members. Okay, so if we compare the theories, with all that covered, here's Craig's Hilbert's Hotel argument. Premise 1, an actual infinite cannot exist. Premise 2, an infinite temporal regress of events is an actual infinite. Therefore, an infinite temporal regress of events cannot exist. In short, actual infinites are impossible, according to this argument, and since an infinite temporal regress of events counts as an actual infinite, it follows that such a regress is impossible. But if it's possible for the past to be beginningless, then an infinite temporal regress of events is possible. Since we just concluded that the latter isn't possible, it follows that it's not possible for the past to be beginningless. In other words, the past must have had a beginning. This, in turn, is taken to establish the Kalam's second premise, according to which the universe began to exist. Now, note that Craig is claiming that actual infinites are metaphysically impossible here. This just means that there's no way that reality could be such that actual infinites exist. Importantly, metaphysical impossibility is different from logical impossibility. Something is logically impossible just in case it entails a contradiction, like something of the form P and not P. Now, everything that's logically impossible is metaphysically impossible, since there's no way that reality could be such that contradictions obtain. Sorry, J.C. Beale and Graham Priest, who think that there are true contradictions. But not everything that's metaphysically impossible is logically impossible. That is, there are some things which are metaphysically impossible, but yet they are logically possible. They're not strictly speaking contradictory. They don't take a form of P and not P, or entail anything of the form P and not P, just by dint of their logical structure. But nevertheless, they genuinely cannot obtain. They cannot obtain in reality. For example, prime numbers cannot produce prime ministers. But there's nothing logically inconsistent or strictly contradictory about the claim that prime numbers produce prime ministers. Instead, you have to know something about the very nature of prime numbers and know something about the nature of prime ministers. And so we get certain necessary truths, metaphysically necessary truths, deriving from the nature of these sorts of things that just preclude them from being able to produce one another. It isn't a logical fact. So that's a case of something that's metaphysically impossible, though not logically impossible. Here's how Craig clarifies his argument in light of this distinction. These remarks make clear that when it is alleged that an actual infinite cannot exist, the modality at issue is not strict logical possibility. Rather, what is at issue here is so-called metaphysical possibility, which has to do with something's being realizable or actualizable. In other words, something's being able to obtain. The fact that the argument is framed in terms of metaphysical modality also has an important epistemic consequence. Since metaphysical modality is so much woollier a notion than strict logical modality, there may not be the sort of clean, decisive markers of what is possible or impossible that consistency in first-order logic affords for strict logical modality. Arguments for metaphysical possibility or impossibility typically rely upon intuitions and conceivability arguments, which are obviously much less certain guides than strict logical consistency or inconsistency. The poorly defined nature of metaphysical modality cuts both ways dialectically. On the one hand, arguments for the metaphysical impossibility of some state of affairs will be much more subjective than arguments concerning strict logical impossibility. On the other hand, such arguments cannot be refuted by facile observations to the effect that such states of affairs have not been demonstrated to be strictly logically inconsistent. So with all that out of the way, let's now turn to Craig's justifications for each premise of the argument, beginning with the second premise, that an infinite temporal regress of events is an actual infinite. So to see this premise's truth, it suffices to recognize that an infinite temporal regress of events can be placed in one-to-one correspondence with the natural numbers. Right? Just simply pair the event of yesterday with the number 1, the day before with the number 2, the day before that with the number 3, and so on ad infinitum, right? The sort of proletariat capitalist revolution is sort of, it's coming. As Craig writes, the second premise is obvious enough, for if there has been a sequence composed of an infinite number of events stretching back into the past, then the set of all events in the series would be an actually infinite set. Let's turn then to the first premise. Why should we believe that actual infinites cannot exist? Well, according to Craig, actual infinites would have various quote-unquote absurd properties that make them impossible. By way of illustration and argument, he asks us to consider the case of Hilbert's Hotel, and this is where the argument gets its name, the name Hilbert's Hotel argument. So we're going to play this clip here. Oh, and by the way, all the videos that I'm going to be playing in this video are going to be on 1.25 times speed. So that's just a heads up. But anyway, let's get into the video itself.
David Hilbert was perhaps the greatest mathematician of the 20th century. And to illustrate the strange nature of the actual infinite, he invites us to imagine a hotel that has an infinite number of rooms in it. Moreover, he says, imagine that every room is occupied. Now, you have to have that firmly in mind. There is a flesh and blood person in every single room throughout the infinite hotel. Now, Hilbert says, suppose somebody shows up at the guest registry wanting to check in. The proprietor says, of course, no problem. And he moves the person who was in room 1 into room 2. The person who was in room 2, he puts in room 3. The person who was in room 3, he puts in room 4, on out to infinity. As a result, room 1 now becomes vacant, and the new person is easily accommodated. And yet, before he came, all the rooms were already full. Then Hilbert says, imagine that an infinite number of new guests show up at the front desk, and again, every room is already occupied. No problem, says the manager. And he moves the guest in room 1 into room 2. He moves the guest who was in room 2 into room 4. He takes the guest who was in room 3 and puts him in room 6, putting every guest in the room number double his own. Well, since any number multiplied by 2 is always an even number, right? All of the odd-numbered rooms become vacant, and therefore the infinity of new guests is easily accommodated. And yet before they arrived, every room was already full. I think these sorts of absurdities show the impossibility of the existence of an actually infinite number of things, because there's nothing about the illustration that hangs on it being a hotel. When you have an actual infinite, you generate these kinds of crazy situations that I think are plausibly metaphysically impossible.
So Nate, that's a thought experiment that Craig likes to use as an illustration of the allegedly absurd aspects of actually infinite collections. And in Craig's published work, he identifies, or at least claims to identify, at least 4 aspects of Hilbert's Hotel that are absurd. And you got a glimpse into it, I think at least 2 of these in the video that I just provided. So first, despite being full, right, Hilbert's Hotel can accommodate new guests by mere rearrangement. That's the first allegedly absurd aspect of Hilbert's Hotel. Second, if one or even infinitely many new guests are accommodated in Hilbert's Hotel, there's still the same number of guests as before they arrived. As Craig writes in the case of adding a new guest, there are now no more persons in the hotel than there were before. The number is just infinite. How can this be? The proprietor just added the new guest's name to the register and gave him his keys. How can there not be one more person in the hotel than before? Similarly, if one or even infinitely many guests leave the hotel, there can still be the same number of guests as before they left. As Craig writes, Hilbert's hotel is even stranger than the German mathematician made it out to be. For suppose some of the guests start to check out. Suppose the guest in room number 1 departs. Is there not now one fewer person in the hotel? Not according to infinite set theory. The same is true if all of the infinitely many odd-numbered guests check out, right? There would still be the same number afterwards as before. So that's a second general absurdity attending Hilbert's hotel and actual infinite collections more generally. The third alleged absurdity that Craig identifies is that one can subtract identical quantities from identical quantities to yield divergent results. If the guests in rooms other than, say, the first 3 checked out, the hotel would be virtually emptied. Only 3 guests would remain. But if the guests in every other room checked out, infinitely many guests would remain. And yet precisely the same number of guests would have checked out, namely Aleph null. In fact, this entails a contradiction according to Craig. We have Aleph null minus Aleph null equals 3, right, in the case of all the guests 4 and above checking out. And we also have Aleph null minus Aleph null equals Aleph null in the case of removing all the odd-numbered guests, let's say. So since Aleph null minus Aleph null just is Aleph null minus Aleph null, right? These two are identical to one another. By the transitivity of identity, or the transitivity of equality, we can have 3 equals Aleph null, which is, of course, a contradiction. No, that 3 is clearly different from Aleph null. Transfinite arithmetic, that is, addition and subtraction concerning infinite quantities, avoids this implication, avoids this contradiction, by leaving subtraction undefined for infinity. But while that might keep things working smoothly in mathematics, Craig points out that in reality, one cannot stop people from checking out of a hotel if they so desire. In this case, one does wind up with logically impossible situations, says Craig, such as subtracting identical quantities from identical quantities and finding non-identical differences. So that's a third allegedly absurd aspect of Hilbert's hotel. And fourthly and finally, Hilbert's hotel points to a paradox involving actual infinites that we can call Galileo's paradox, after, of course, Galileo, who famously took note of it. The paradox involves 3 jointly incompatible principles: Hume's principle, Euclid's principle, and the actual infinite principle. So first, Hume's principle. This says that if there's a one-to-one correspondence between 2 sets, then they must have the same number of elements. The second principle is Euclid's principle. The number of elements in a set must be greater than the number of elements in any of its proper subsets. That is, if one set contains all the elements in another set, plus some additional elements, then the number of elements in the first set is greater than the number of elements in the second set. And thirdly, the actual infinite principle, which says that there can be a set with infinitely many members, that is, a set with Cantor's property. Now, it's pretty clear that these 3 principles are mutually incompatible. Take any 2 and you can't have the third, right? So suppose that there can be a set with infinitely many members, which has Cantor's property. Well, Cantor's property, remember, means that a whole set can be put in one-to-one correspondence with infinitely many of its proper subsets. So if it can be put in one-to-one correspondence with infinitely many of its proper subsets, well, then they must have the same number of elements. But according to Euclid's principle, right, the number of elements in a set must be greater than the number of elements in any of its proper subsets. And so they can't have the same number of elements. So that's how you can see that they're kind of mutually incompatible. And since they're mutually incompatible, we must deny at least one principle among these 3. Now, mathematicians typically deny Euclid's principle, opting to restrict its scope only to finite sets. But as Craig writes, the metaphysician wants to know why, in order to resolve the inconsistency among 1 through 3, it is 2 that should be jettisoned or restricted. And that's Euclid's principle. Why not reject 3 instead of the apparently innocuous 1 or 2? It certainly lacks the innocuousness of those principles, and giving it up would enable us to affirm both 1 and 2, says Craig. The idea is that because both Hume's principle and Euclid's principle are, by Craig's lights, intuitively plausible, we should reject the actual infinite principle, which in turn entails accepting that actual infinites cannot exist. In light of these 4 absurdities, Craig concludes that Hilbert's hotel is metaphysically impossible. He then reasons from the impossibility of Hilbert's hotel to the impossibility of actual infinites more generally, and thus to the truth of premise 1. As he says, if an actual infinite number of things could exist, they could be numbered and manipulated just like the guests in Hilbert's hotel. Since nothing hangs on the illustrations involving a hotel, the metaphysical absurdity is plausibly attributed to the existence of an actual infinite. Thus, thought experiments of this sort show, in general, that it is impossible for an actually infinite number of things to exist in reality. So, concludes Craig, premise 1 is true of the Hilbert's hotel argument. Actual infinites cannot exist. Having justified each premise and explaining how the conclusion is taken to support premise 2 of the Kalam, we can now consider 9 responses to the argument. Woot woot. Okay, so we are getting into the fun and juicy stuff. It's so juicy. Insert an appropriate joke. Okay, so the first response from Disambiguation. So the first response focuses on the first and second allegedly absurd aspects of Hilbert's Hotel. The response is that these alleged absurdities rest on subtle ambiguities, and when we make the relevant disambiguations, the quote-unquote absurdities disappear. Consider again the first absurd aspect. Despite being full, right, the hotel can accommodate new guests. Well, isn't that just absurd? No, it's not. There are two ways to understand fullness, and given these two ways, the principle that a full hotel cannot accommodate new guests is either inapplicable to Hilbert's Hotel or simply false. The first way to understand fullness is that a hotel is full just in case no additional guests can be added to the hotel. But in that case, of course, Hilbert's Hotel is simply not full, right? You can add new guests to it. In which case, the principle that a full hotel cannot accommodate new guests is just irrelevant to the Hilbert's Hotel. It's inapplicable to it. The second way to understand fullness is that a hotel is full just in case every hotel room is occupied. But in that sense, while Hilbert's Hotel is full, the principle that a full hotel cannot accommodate new guests turns out to be false for infinite hotels. And so either way, there's really no absurdity here. Now, you could, of course, claim that any hotel in which each room is occupied cannot accommodate new guests. But why should we accept that claim, right? As far as I can tell, this is just a flat assertion. In fact, we could equally take Hilbert's Hotel to serve as a counterexample to the universal applicability of that claim. While it's true of finite hotels, it would obviously be false of infinite hotels. In fact, to insist on its universal applicability is simply to insist that there couldn't be infinite hotels, which is precisely the question at issue. More generally, one is only in a position to think Hilbert's Hotel isn't a counterexample to the aforementioned claim if one antecedently rejects the possibility of Hilbert's Hotel, which, again, is the very question at issue in this dispute. Philosopher Felipe Leon has a nice analysis of this first allegedly absurd aspect of Hilbert's Hotel. He points out that the argument rests on the following crucial premise. No hotel can transition from having no vacancies to having vacancies without removing any of its occupants, and no hotel can transition from having vacancies to having no vacancies without adding new occupants. That is, merely moving occupants around is not sufficient. Here's how Felipe Leon challenges this premise. Granted, no hotel occupying a finite region of space and with a finite number of rooms could transition from having no vacancies to having some, and vice versa, by just moving some of its occupants around. But these things aren't obviously true for a hotel occupying an infinite region of space and having infinitely many rooms. For one might think that what makes such transitions impossible for finite hotels is that having spatial boundaries leaves some occupants with nowhere to go in such transitions. For example, the person in the room at the end of the hotel, right? They're going to have nowhere to go in such transitions. But since an infinite hotel of the relevant sort lacks a spatial boundary in at least one direction, there is always somewhere for each tenant to go, since there is no last room at the end of the hotel. Now consider the second allegedly absurd aspect of Hilbert's Hotel. Remember, that second allegedly absurd aspect was that one or even infinitely many guests can be added or removed without changing the number of guests in the hotel. Surely, though, there are more guests after the addition of guests and fewer guests after the removal of guests, right? Isn't that just an absurd aspect of Hilbert's Hotel? Well, again, no, it's not. After guests are added, there certainly are more hotel guests in the following sense. All the guests present before the addition are present after the addition, and other guests are present as well. This is a perfectly adequate, perfectly intelligible sense of more guests, right? The hotel afterwards has all the guests as before, and then some. The only sense in which there aren't more guests is the sense in which the cardinality of the set of guests after the addition is the same as the cardinality of the set of guests before the addition. But there's nothing absurd about this. In standard Cantorian set theory, two sets having the same cardinality is just defined as there being a one-to-one correspondence between them. And it's obvious that there's a one-to-one correspondence between the set of guests before new guests arrive and the set of guests after the new guests arrive. So yes, the cardinality of the collection of guests doesn't change as a result of the addition, but there's nothing absurd about that. It's definitionally true. Similar things are true of the removal of guests, right? There's a perfectly adequate sense of fewer guests on which the hotel, after removing guests, does have fewer guests. Specifically, the set of guests after removal is a proper subset of the set of guests before removal. All the guests in the hotel after removal were present before the removal, but there were guests before the removal that are no longer present after the removal, right? There's nothing absurd there. And the only sense in which there aren't fewer guests is the sense in which the cardinality of the set of guests after removal is the same as the cardinality of the set of guests before the removal. But as before, right, there's nothing absurd about this. In fact, it's definitionally true. So neither of the first two allegedly absurd aspects of Hilbert's Hotel are actually absurd. The first absurdity dissolves when we disambiguate the notion of fullness, whereas the second absurdity dissolves when we disambiguate the notion of more guests and fewer guests. In the next two responses, then, I'll tackle the third and fourth allegedly absurd aspects of Hilbert's Hotel, respectively. So, response number 2, transfinite confusion. So, recall the third allegedly absurd aspect of Hilbert's Hotel, that is to say, one can subtract identical quantities from identical quantities. Okay. Back to Joe voice. Recall the third allegedly absurd aspect of Hilbert's Hotel, right? You can subtract identical quantities from identical quantities to yield different results, leading to contradictions like 3 equals Aleph null. Craig focuses on two operations to make this vivid. The first manipulation, or the first operation, we're just going to call them manipulations. The first manipulation involves removing all the even-numbered guests, whereas the second manipulation involves removing all the guests numbered 4 and above. But, as philosopher Louis Swingrover points out in his article Difficulties with William Lane Craig's Arguments for Finitism, this reasoning is just confused. For the sake of simplicity, let's simply treat the guests as numbers. So the guest in room 1 is treated as the number 1, the guest in room 2 is treated as the number 2, and so on. Let's now consider Craig's first manipulation, which amounts to subtracting all the even numbers from all the natural numbers. So we're going to let n be the set of natural numbers, so n is equal to 1, 2, 3, 4, and so on. We're going to let e be the set of even numbers, so the set of 2, 4, 6, 8, 10, 12, and so on. And we're going to let o be the set of odd numbers, so o is 1, 3, 5, 7, 9, 11, and so on. Craig aims to represent the first manipulation as follows. So we're removing all the even-numbered guests from all the natural-numbered guests. And so he's representing this manipulation as follows. N minus E, and that's minus in the sense of subtraction, N minus E equals O. Now, importantly, the cardinality, or number of elements, of each of these sets, each of N, E, and O, is infinity, right? Or Aleph null, right? So the cardinality of N is Aleph null, the cardinality of E is Aleph null, and the cardinality of O is Aleph null, right? Those bars around the sets, those bars represent the cardinality of the set. So bars around N is just the cardinality of N. So, according to Craig, we can plug in the cardinalities of the sets N, E, and O to yield the following equation. Aleph null minus Aleph null equals Aleph null, right? So we had N minus E equals O, and then we have the cardinalities of the relevant sets, and so we just plug these in here. Aleph null minus Aleph null equals Aleph null. So that's the first operation. Now consider Craig's second manipulation of subtracting all the numbers greater than 3 from all the natural numbers. So again, let N be the set of natural numbers, so N is 1, 2, 3, and so on. F be the set of natural numbers 4 and above, so F is 4, 5, 6, 7, 8, 9, 10, and so on. And T be the set of natural numbers up to and including 3, so T is just the little tiny set 1, 2, and 3. So again, Craig aims to represent his second manipulation as follows. N minus F equals T. But not all of these sets contain an infinite number of members, right? So the cardinality of N is Aleph null, the cardinality of F is Aleph null, and the cardinality of T is 3. So again, doing our little plugging in that Craig wants to do, according to Craig, right, we can plug in the cardinalities of the sets N, F, and T to that equation here to yield the following. Aleph null minus Aleph null equals 3. So, concludes Craig, we have both of the following. From the first manipulation, we have Aleph null minus Aleph null equals Aleph null, and from the second operation, we have Aleph null minus Aleph null equals 3. But since Aleph null minus Aleph null equals Aleph null minus Aleph null, right, since these two are identical to one another, we can basically just put the 3 up here. That's the transitivity of equality, in which case we get Aleph null equals 3, which is a contradiction. But as Swingrover points out, this reasoning equivocates between the relative complements of sets and the differences between their cardinalities. Okay, so don't worry, because I'm going to explain this, right? I'm going to explain what a relative complement is, and so on, right? So again, the fundamental problem with this reasoning is that it equivocates between the relative complements of sets and the differences between their cardinalities. So taking the relative complement between two sets, also known as taking their set difference, is a standard mathematical operation performed on two sets. So here, for instance, is a formal definition of set difference from Wolfram MathWorld, the web's most extensive mathematics resource. So set difference, as they point out, the set difference, A \B is defined as the set of all x such that x is an element of A and x is not an element of B. Okay, that might not be very helpful, so I'm going to give you a relatively intuitive way to understand relative complements. Oh, and this is read as, you could read this as the set difference between A and B, but you could also read this as the relative complement of B in A. Okay, so that's different ways of reading it. Okay, so let me make this intuitive for you. Let me help you understand it. So the relative complement of B in A, represented as A backslash B, also known as, set subtracting B from A, the relative complement of B in A is the set of members in A, but not in B, okay? So for example, suppose A is the set 1, 2, and 3, while B is the set of 1 and 3. The relative complement of B in A is the set of members contained in A that are not contained in B. Okay, since the number 2 is the only member of A that isn't contained in B, right? The relative complement of B in A just is the set containing 2, right? So thus we have the relative complement of B in A is the set containing the number 2. You can also read this as the set difference between A and B is the set containing 2, but I think it's clearer if you just say the relative complement of B in A is the set containing 2. So think about it like this, right? You're basically subtracting or removing B's elements from A's elements, right? So set A contained the numbers 1, 2, and 3. Once you subtract B's elements, which are the numbers 1 and 3, from A's elements, you're left only with the number 2, right? So you're basically just taking away from A the members that it shares in common with B, right? So this is why relative complements are also called set differences, because you're kind of like removing or subtracting or taking away from the first set the members it has in common with the second set. Okay, that's kind of why it's called set differences. There's a kind of intuitive sense in which you're taking a difference between the sets here. But notice that we can also perform different operations with sets A and B. So for instance, we can take the difference in the sense of subtraction, right? We can take the difference between the cardinality of A, which is a quantity or a number, and the cardinality of B, which is a quantity or a number, represented as follows. The cardinality of A minus the cardinality of B equals question mark. Since A above had 3 members and B above had 2 members, the answer to this equation here is just 1. The cardinality of A minus the cardinality of B is 3 minus 2, which is, if you recall from kindergarten, 1. Well, maybe you don't learn subtraction in kindergarten. Maybe that's first grade. That's a step up. Now, given what I've just explained, we know that the relative complement of B in A happens to have the same cardinality as the difference between the cardinalities of A and B, right? So the difference between the cardinalities of A and B was just 1. And the cardinality of the relative complement of B and A was just the set containing the number 2. And the cardinality of that set is 1, right? Because it has 1 member. So the cardinalities are the same in this case. The cardinality of the relative complement of B and A is 1. The cardinality of that set is 1. And also the difference between the cardinalities of A and B is also 1, okay? So we know here that the relative complement of B and A happens to have the same cardinality as the difference between the cardinalities of A and B. But this isn't always the case. So we can let A again be the set 1, 2, and 3, but now we're going to let C be the set 1, 3, and 4. The relative complement of C in A is 2. It's just the set containing 2. Since 2 is the only element in A that isn't in C, right? Again, when you're doing set subtraction, you take away from the first set what it shares in common with the second set. So since 4 isn't shared in common, you just ignore that, right? 1 and 3 are shared in common, so you take those away from A, and you're just left with 2. So the relative complement of C and A has only 1 member, and so its cardinality is 1. But the difference between the cardinalities of A and C is 0, right? Since each of A and C has 3 members. And so 3 minus 3, again, if you recall from first grade, is 0. So what this shows us, right, what this little demonstration here, there's a point to this, right? I'm not just blathering on about math for no reason. What this shows us is that finding the relative complement of one set in another and finding the difference between their cardinalities are clearly not the same operation, right? So we have distinct operations here. They're different. They're importantly different, as Swingrover points out. What we need to ask then, so this is a crucial question in evaluating the third alleged absurdity that William Lane Craig purports to ascribe to Hilbert's Hotel and actual infinites more generally. What we need to ask is the following question. What operation is Craig performing in the various manipulations of hotel guests? Well, as Swingrover points out, the answer is obvious. Craig's examples describe relative complements, not differences between cardinalities. He defines the members of each set and finds the elements belonging to one set, but not the other. This defining of membership is necessary to arrive at sets of different cardinalities, right? If he were only to describe the removal of an undefined infinite quantity from an undefined infinite quantity, well, then the result would be undefined. To see this, just imagine removing an infinite number of marbles from an infinite number of marbles. We can ask, how many marbles would remain? Well, There's not enough information provided here to determine the answer. It's not as if the operation is arbitrarily prohibited, as Craig alleges. It's just that without knowing which precise members one is to remove from a set containing which members, one does not know what the cardinality of the resultant set will be. But then if one does know the definition of the membership of each set, then the cardinality of the resultant set is unique, and it would be incorrect to express the operation as Aleph null minus Aleph null. So the crucial thing to see then is that in the manipulations Craig describes involving hotel guests, we're actually taking the relative complement of one well-defined set in another well-defined set. And in each case, a unique, well-defined set results. Craig has to specify that we're taking the even-numbered guests, which is a well-defined set, and we're removing them from the natural-numbered guests, right, which is another well-defined set. And you take the relative complement of the former and the latter, and that gives you the set of the odd numbers, right? And that's a unique, well-defined set that results. No contradiction here whatsoever. Importantly, though, Craig misleadingly characterizes each operation as if it were the subtraction of an undefined infinite quantity from an undefined infinite quantity, right? Return to that marble example above. As we've seen, however, this is not the operation being performed in the case of Hilbert's Hotel. The operation being performed isn't the subtraction of transfinite cardinals. It's the relative complement of one well-defined set in another well-defined set to yield a unique answer. And depending on which relative complements you take, different sets can result. But that's only because you took different relative complements, right? You have different equations, and no contradiction results. As Swingrover notes, the contradictions cannot be reached if the equivocations are not made. The relative complement of a well-defined transfinite set in another well-defined transfinite set always yields a unique result. So the moral of the story here is that Craig equivocates between the relative complement of two sets on the one hand, and the difference between the cardinalities of the two sets on the other. These are crucially different, and the operation performed when hotel guests are removed is the relative complement of two sets, which always yields a unique, well-defined set and hence never yields a contradiction. Craig is simply wrong then when he says that Hilbert's Hotel involves logical contradictions. He's flatly wrong. Now, one might object that Craig has already anticipated any appeal to the relative complement between sets, that is, to their set differences. Craig writes, for instance, I think this is just in a footnote buried in his Blackwell Companion to Natural Theology chapter with James D. Sinclair, he says, "It will not do, in order to avoid the contradiction, to assert that there is nothing in transfinite arithmetic that forbids using set difference to form sets. Indeed, the thought experiment assumes that we can do such a thing. Removing all the guests in the odd-numbered rooms always leaves an infinite number of guests remaining, and removing all the guests in rooms numbered greater than 4 always leaves 3 guests remaining. That does not change the fact that in such cases, identical quantities minus identical quantities yields non-identical quantities, a contradiction. The problem, though, is that this is just obviously confused. It does change the fact that in such cases, identical quantities minus identical quantities yields non-identical quantities, since it shows that the relevant operation being performed is not actually subtraction. As I've explained, the operation being performed is not the subtraction of one cardinal number, a quantity, from another cardinal number, another quantity. Instead, the operation being performed is taking the relative complement of one set in another. No contradiction ensues from the latter operation, and it is only the latter operation being performed when guests are removed from Hilbert's Hotel. So yes, it does change the fact that in such cases, quote-unquote identical quantities minus identical quantities yields a non-identical quantities. It does change that because the relevant operation being performed isn't minus, it isn't subtraction. It's relative complements. It's taking the relative complements of one set in another. Now, of course, you might object that we actually are still subtracting guests, right? After all, aren't we removing guests? And isn't removing physical objects from a given collection sufficient for subtraction? Well, actually, no, it's not. Arithmetic subtraction is an abstract function relating numbers, not physical objects, and it has various formally defined properties in accordance with a specific mathematical system. Subtraction allows us to capture or represent various manipulations that we might make in reality, but subtraction as such is confined to the mathematical realm. And I've already explained why it is set difference, rather than arithmetic subtraction, that captures the relevant manipulations performed when guests are removed from the hotel. Now, James Fodor, in his book Unreasonable Faith, wonderfully summarizes the central fallacy Craig commits in his argument from transfinite subtraction, and what James says is worth quoting at length. Craig's argument is that while in Cantor's system of transfinite arithmetic, okay, I'm not going to do the Australian accent, compare the theories. Craig's argument is that while in Cantor's system of transfinite arithmetic, inverse operations such as subtraction are prohibited or left undefined, In the real world, there would be nothing preventing an infinite number of guests from actually checking out of Hilbert's hotel. This inability to account for the real possibility of subtraction of infinite quantities, Craig argues, shows that actual infinities cannot exist in the real world. This argument is fallacious, however, because it exhibits a misunderstanding of the meaning of subtraction. To solve the equation x minus y equals z, for example, is just to ask what number added to y will give x. The reason such an operation cannot be defined in transfinite arithmetic is because when dealing with infinite sets, this question has no unique answer. For example, if both x and y are equal to Aleph null, then z could be any number from 0 up to Aleph null and still satisfy the relation. Since, by the way, transfinite arithmetic works, Aleph null plus 1 equals Aleph null plus 2 equals Aleph null plus 3 equals Aleph null plus Aleph null equals Aleph null, and so on. Thus, in Cantor's arithmetic, subtraction is prohibited for good reason, because it cannot be defined in a general way that yields a single definite answer. It is still possible, however, to meaningfully answer questions involving specific instances of removing items from infinite sets. For example, the set of natural numbers z equals 1, 2, 3, etc. has cardinality Aleph null. And if all the odd numbers are removed, the remaining subset, the even numbers, still has cardinality Aleph null. We can therefore say that the cardinality of the set of z with the odds removed is equal to the cardinality of z itself. By contrast, if we take the set of natural numbers and then remove the subset of all numbers greater than 100, the resulting set has a cardinality of 100. Thus, in any specific case of removing particular elements from an infinite set, we are able to determine the cardinality of the set that is left over, which is called the relative complement, denoted A\B, or the relative complement of B in A. Craig's argument fails because he does not appreciate the difference between subtracting the cardinality of B from the cardinality of A and the cardinality of the relative complement of B in A. The former here, the cardinality of A minus the cardinality of B, refers to the difference in the size of sets A and B, and involves the operation of subtraction, which is undefined for infinite sets. The latter, however, refers to the size of the relative complement of sets A and B, and is defined and can be carried out even for infinite sets. It is only this latter operation that is required for real-world operations involving specific infinite sets. Right? After all, in the real world, we never observe quote-unquote subtraction in the abstract. What we observe are specific instances of taking some items away, in particular well-defined specified items away, from a set of some others. And then we determine the size of the set that is left over. In any real-world case involving a specific, even infinite number of guests checking out of a hotel, therefore, the size of the set of guests remaining at the hotel would always be uniquely defined. As such, the fact that the abstract notion of subtraction is not defined for infinite sets does nothing to undermine the possibility of an actual infinity existing in reality. In short, there's a manifestly clear difference between the removal of an infinite subset from an infinite set of real entities, on the one hand, and the attempted subtraction of one transfinite cardinal number from another, on the other hand. It is only by eliding this difference that Craig's argument has any purchase. Here's actually a more intuitive way to see why Craig's argument is mistaken, explained by philosopher Daniel Linford.
The issue is supposed to be that there's two different ways of subtracting infinite quantities. So if the Hilbert Hotel is full in the sense that there's a person in every room, and suppose that on each room of the hotel there's a positive integer, so there's one room for every positive integer. If we take out all of the, take out everyone from all of the rooms, then we've taken away an infinite number. If we take away just the people who are in, say, the odd numbered rooms, then I've likewise taken away a countably infinite number. You might think, wait a minute, I've taken away the same quantities in both cases, but I've reached different answers. Isn't that a problem? There's a very simple reply to this, which is just to say, look, you actually didn't take away the same things. It's a mistake to think that the right way to subtract infinities is to subtract the cardinalities of these two collections. That's not the right thing to do. What we're doing is we're taking an infinite set, and then we're subtracting another infinite set, and there's two different infinite sets you could subtract. You can either subtract the set of all the rooms, or you could subtract the infinite set that's all the odd numbered rooms. Those are two different sets. And so when you subtract the two different sets, of course you get two different answers. There's no inconsistency there.
But I suppose it seems intuitively implausible, because you think of the cardinality of Aleph naught as like a number, right? And then you think of the cardinality of all the even numbers as the same number, Aleph naught, and then you're like, well, I'm taking the same number away from the same number, and in finite arithmetic, that does a particular thing, but it doesn't do in this case. And
right, and it's just a mistake to think that that's the way that cardinalities work. Because, by the way, the other thing to be said here is that there are ways of mathematically defining transfinite numbers for which this isn't a problem. There are notions of transfinite number in which when you subtract away one from them, you get a different transfinite number. They're different from this cardinality concept. But again, this is the same point I raised before, that mathematicians and set theorists and logicians and so forth, people working in this area, have a plurality of ways of talking about transfinite numbers. And for some of them, it makes sense to talk about subtraction giving sensible results, and for others, it doesn't. There's a question here about how exactly you want to model this kind of process. But I think, when we're subtracting, I think that the most obvious thing to do when we talk about subtracting these infinite sets is that the operation that we're describing is the operation of taking a set and then taking away two different sets from it. Described that way, there's nothing counterintuitive about the fact that you get two different results. Suppose I've got a collection of fruit in a table, say 3 different pieces of fruit again,
Yeah.
and but there are different kinds of fruit, like maybe like 2 bananas and an apple or something. And then I tell you that I take away one kind of fruit, one piece of fruit, but I don't tell you what kind of fruit I take away. And now I ask you, how many apples do I have on the table? You wouldn't really answer that question either. So and that's an example where, it matters what kind of process you actually went through. It matters like how you did the operation.
So as he was pointing out at the end there, there's no mystery, there's no counterintuitiveness in getting different cardinalities of sets remaining if you remove different sets from that, right? Depending on which set you took away from the original set, it's no surprise whatsoever that you get a different resulting set. It's no surprise whatsoever, for instance, that you get a set containing 3 elements in one case and infinitely many elements in another case, because you performed different operations. You took different relative complements. You took the relative complement of one set in the original set, and then a relative complement of a different set in the original set. So depending on which set you take away, of course you can get different end results. There's nothing counterintuitive about this. There's nothing unintelligible about this. There's nothing unclear about this. This is all perfectly benign, perfectly innocuous, and perfectly obvious. Interestingly, also, the same observation is made time and again in other publications, right? Philosopher Wes Morriston, for instance, in connection with an infinite library version of the Hilbert's Hotel thought experiment, writes that Craig claims that it is quote-unquote arbitrary to deny that inverse operations apply to infinite sets, leaving infinity minus infinity undefined. In the real world, he says, addition and subtraction must always be possible. If a person checks out a book from the library, he has quote-unquote subtracted one book. If he checks out all the odd-numbered books, he has quote-unquote subtracted infinitely many books, and so on. So if a mathematician chooses to define a transfinite number, such as Cantor's Aleph null, for which this operation is not possible, he is free to do so, but no set having that number of elements can then be instantiated in the real world, or so Craig's argument goes. This argument, says Wes Morriston, is badly confused. If a person checks out one or more books, he does indeed remove them from the library, but he is not subtracting them in the arithmetical sense. And even if, and that's a point that I was making earlier, by the way, we're not subtracting things in the physical world. Subtraction is an abstract function relating numbers. So again, if a person checks out one or more books, he does indeed remove them from the library, but he is not quote-unquote subtracting them in the arithmetical sense. And even if ordinary arithmetical subtraction is undefined for transfinite numbers, it doesn't follow that physically removing books from an infinite library is similarly undefined, much less that removing books from it is impossible. What follows is only that, since subtraction is undefined for infinite quantities, we cannot automatically assume that the number of books is smaller after some of them have been removed. That is indeed a characteristic of the actual infinite, of course, but it is hardly a logical contradiction. This point can be generalized as follows. Addition and subtraction of numbers is one thing. Constructing a new set by adding in new members or removing old ones is quite a different thing. Operations of the second sort may be possible, even when operations of the first sort make no sense or are undefined. It is only by confounding the two sorts of operation that Craig can imagine that he has derived a logical contradiction from the actual infinite. Alex Malpass and Wes Morriston argue similarly in their 2020 article, Endless and Infinite. What's been shown here is merely that in the case of an infinite collection, the remainder, after quote-unquote taking away some of its members, depends not just on the number of items taken away, but on which ones are taken away. And once those are identified, it is a perfectly straightforward matter and a perfectly non-contradictory matter to find a unique remainder. And of course, no contradiction emerges. And finally, this is important, the final objection to Craig's argument from inverse operations, right? The inverse operations are subtraction and division, by the way. The final objection to Craig's argument from the inverse operations involving transfinite numbers derives from Graham Oppie. And Craig's argument from inverse operations, that's just a different way of referring to Craig's third alleged absurdity afflicting Hilbert's Hotel and actual infinites more generally. So anyway, this criticism comes from Graham Oppie, and it's quite a cogent criticism. Oppie writes that in Cantorian formulations of transfinite arithmetic, the inverse operations in question are conventionally prohibited or excluded. But there are many non-Cantorian formulations of transfinite arithmetic in which the inverse operations are allowed. Oppie focuses on three such non-Cantorian formulations: Abraham Robinson's non-standard analysis, Edward Nelson's internal set theory, and J.H. Conway's number construction in his book on numbers and games. Now, don't worry, we won't get bogged down in the details of each of these non-Cantorian formulations of transfinite arithmetic. What matters for present purposes is that Craig's point about the prohibition on inverse operations in transfinite arithmetic hinges entirely on the Cantorian formulation thereof. But there are other models of transfinite arithmetic for which the relevant operations are not prohibited, in which case Craig's argument simply falls flat. To avert this problem, Craig would need to demonstrate why only Cantorian formulations of transfinite arithmetic are mathematically correct or legitimate. But as of yet, of course, he has done no such thing, and unless and until this monumental task is successfully completed, Craig's argument falls flat. It utterly fails. By the way, I just want to put some of these things on your radar. Here is Robinson himself, right? This is Robinson. Yes, indeed. And then here's his book that Graham Oppie is referring to. Here is Nelson, right here. It looks like he's on a little ferry or something. And then here's the paper that Graham Oppie is referring to, Internal Set Theory, a New Approach to Non-Standard Analysis. And then finally, here is J.H. Conway. He's an absolute genius, by the way. And here is his book on numbers and games. What we learn from all of the preceding is that the third allegedly absurd aspect of Hilbert's Hotel fundamentally rests on confusions upon confusions concerning subtraction and transfinite arithmetic. As such, nothing here counts against the possibility of Hilbert's Hotel and actual infinites more generally.
Mission failed. We'll get them next time.
Onward we march to my third response out of 9, Galileo's non-paradox. So far, we've seen that none of the first three aspects of Hilbert's Hotel are actually absurd, and the task of my third response is to show that the fourth allegedly absurd aspect of Hilbert's Hotel succumbs to the same fate. Recall the fourth absurdity captured in Galileo's paradox, which involved three jointly incompatible theses. Hume's principle, according to which sets must have the same number of elements if there's a one-to-one correspondence between them. Euclid's principle, according to which any set must have a greater number of elements than its proper subsets, and the actual infinite principle, according to which an actually infinite set of things is possible. Possible. I don't know why I said it like that. Possible. There we go. Possible. Craig invites us to accept Hume's principle and Euclid's principle as universally and unqualifiedly true, and hence urges us to reject the actual infinite principle. But there's a serious problem with this. Why not instead simply reject the universal and unqualified truth of Euclid's principle, opting instead to restrict it only to finite sets? Remember, the burden of proof in this context is on Craig to establish that Hume's principle and Euclid's principle are universally and unqualifiedly true. The burden isn't on me to give some positive reason for restricting Euclid's principle to finite sets. Rather, the burden is on Craig to show why we shouldn't restrict it in this manner. But as of yet, Craig has done no such thing. Now, perhaps Craig will respond that Hume's principle and Euclid's principle, understood in universal and unqualified terms, are super duper really intuitive, and so we have good reason to accept them. But there are several things to say in response. First, it's not clear why we should trust our intuitions when it comes to the cardinality of infinite sets. This is a highly theoretic domain, extremely far removed from our ordinary experience. Our intuitions, after all, have been carved, shaped, and molded solely through interaction with finite collections. Perhaps then we shouldn't expect our intuitions about the cardinal properties of infinite collections to be good guides to the truth. At least I want to pose a challenge to Craig. Why on earth should we accept our intuitions about these highly theoretic domains extremely far removed from our ordinary experience? Why should we expect those to be reliable? Second, so this is my second response, the actual infinite principle might strike one as really intuitive as well. And so the mere fact that Hume's and Euclid's principles strike one as intuitive fails to justify why we should embrace them at the expense of rejecting the actual infinite principle. That should say reject, not embrace, or rejecting, not embracing. Speaking for myself, in fact, consistent, mathematically describable infinite collections seem perfectly innocuous to me. I don't see adequate reason to exclude them from the realm of possibility, and I actually see lots of reasons to include them in that realm. I'm going to go over that in my ninth response. For starters, it seems plausible that there are, for instance, infinitely many numbers. Similarly, I can perfectly well conceive of detailed and consistent scenarios involving actual infinite collections if we assume that detailed and consistent conceivability provides some evidence for possibility. Then I have reason to think that the actual infinite principle is true. Now, of course, if you want to reject that detailed and consistent conceivability provides some evidence or possibility, some defeasible evidence, you're probably going to be doing that on the basis of something like mitigated modal skepticism, which I actually have some sympathies with. But in that case, mitigated modal skepticism is a double-edged sword, because mitigated modal skepticism also is going to be telling us that we shouldn't be trusting our intuitions in these highly theoretical domains, extremely far removed from our ordinary experience, when it comes to possibilities and impossibilities, such as the impossibilities of infinite sets. And so if you want to take that route of responding to me here by going the mitigated modal skepticism route, then you're going to be collapsing, well, almost Craig's entire case for the Hilbert's Hotel argument, because it just rests on applying our intuitions in these highly theoretical domains far removed from our ordinary experience. So anyway, that's a double-edged sword, if you want to take that response to my point here about consistent and detailed conceivability, providing some defeasible evidence for possibility. Okay, so that's my second response. My third response to this point up here is that, at least speaking for myself, right, I actually only find Euclid's principle intuitive for finite sets. When it comes to infinite sets, the intuition utterly dissolves, especially when I come to fully appreciate what infinite sets are like. In fact, I see Euclid's principle as intuitively false for infinite sets, precisely because infinite sets can be put in one-to-one correspondence with, and so are equinumerous with, their proper subsets. Fourth, and finally, we can actually preserve the intuition behind Euclid's principle consistently with Hume's principle and the actual infinite principle. In particular, embracing Hume's principle and the actual infinite principle is perfectly compatible with saying that every whole is greater than its parts, and consequently that every infinite set is greater than every one of its proper subsets. We just have to be super careful with how we understand the term greater. So more specifically, we can distinguish two notions of greater than. In one sense, one set can be greater than another set by having a larger number of elements. That is, one set is greater than another if it has a higher cardinality than the other set. Let's call this notion cardinally greater than. But in another sense, right, one set can be greater than another set by containing all the members that the other set contains and additional members besides that the other set does not contain. And so let's call this notion inclusively greater than. So with these two notions in hand, we can actually capture the intuition that a whole is always greater than its parts, which is the intuition behind Euclid's principle, right? Euclid's maxim is that the whole is always greater than the parts, and that's the intuition behind Euclid's principle that we discussed earlier. So again, with these two notions in hand, we can actually capture the intuition that a whole is always greater than its parts, even assuming that there are infinite collections, and so rejecting the universal and unqualified truth of Euclid's principle. For a whole infinite collection is always inclusively greater than any of its proper subsets, right? Of course, it isn't always cardinally greater than its proper subsets, but that's because cardinality is a strict technical mathematical notion defined in terms of one-to-one correspondence. It's no surprise then that infinite sets are not cardinally greater than many of their proper subsets. But we can still preserve the intuition behind Euclid's principle by recognizing that all infinite sets are indeed greater than their proper subsets, in the sense of inclusively greater. Moreover, given that we can preserve this intuition, it isn't costly to deny the universal and unqualified truth of Euclid's principle. We can instead say that it's only true for all finite collections, while recognizing that infinite collections are always inclusively greater than their proper parts. In this way, we can embrace the actual infinite principle, while simultaneously embracing that wholes are always greater than their parts. We just need clarity on the sense of greater at play. And so in that case, it actually isn't costly at all to deny the universal and unqualified truth of Euclid's principle, since we can preserve the intuition that was behind it. So those are my four responses to this rejoinder that I considered on behalf of Craig with respect to my point up there. And so again, what we learned from all this is that Galileo's paradox fails to support the impossibility of actual infinites. Craig gives us no reason, other than a biographical report of his private intuitions, for embracing both Hume's principle and Euclid's principle, understood in unqualified and universal terms, rather than, say, restricting Euclid's principle to finite sets. And just as I don't share Craig's private intuitions, lots of other philosophers don't either, from Wes Morrison to Alex Malpass to Paul Draper to Dan Linford to Alex Proust to Graham Oppie and well beyond. And speaking of not sharing intuitions, it is to this response that I turn next. Oh, and these are just some of the people that I was just referring to. So there's Graham Oppie. Here's Wes Morrison's paper where he discusses this sort of thing and the evidential salience of the intuitions, Craig on the actual infinite. Here's Wes Morrison himself. Here's Paul Draper's paper where he talks about this, a critique of the Kalam cosmological argument. There's Paul Draper himself. And then this is Daniel J. Linford, where he talks about lots of these sorts of things. This dissertation is actually available on Phil Papers for you to freely read if you're interested. It's called Cosmic Skepticism and the Beginning of Physical Reality. And here's Dr. Daniel Linford. Now, this says PhD candidate, but that's actually mistaken at this point. He's Dr. Daniel Linford. He became Dr. Linford on June 3rd, 2022. And then, of course, here's Proust's Infinity, Causation, and Paradox, where I'm taking that stuff from where he says he doesn't share the relevant intuitions. It's Proust. And yeah, philosophical perspectives on infinity. That's Graham Oppy's book where he says that sort of thing. Okay, response number 4: no intuition of absurdity. So at this point, Craig's Hilbert's Hotel argument is down and out. It's done. It fails. The quote unquote absurd aspects of Hilbert's Hotel and actual infinite collections more generally simply aren't absurd at all. I could end the video there.
No! 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 No!
Alas, we still have 6 more responses to consider. So anyway, here is my 4th response. So the response is that many don't even find the relevant properties of actual infinites unintuitive. And even among those that do, many think that doesn't provide good reason for thinking actual infinites are impossible. Personally, I don't find the properties of actual infinites unintuitive in the slightest. Of course, an infinite hotel could accommodate one or even infinitely many guests by merely shuffling members around. Of course, you could get different guests remaining if you take away different collections of guests. Of course, infinite sets can be put in one-to-one correspondence with their proper subsets. By my lights, there's literally nothing strange or crazy or unintuitive about any of this. It's all perfectly intelligible, perfectly kosher, perfectly benign, perfectly innocuous. In fact, I intuitively find these various properties of infinite collections obviously benign and non-absurd. And what's more, even if I did find them odd or strange or unintuitive, I don't think this would give me good reason to think actual infinites are impossible. After all, boatloads of odd or strange or unintuitive things actually exist and actually are true, right? Quantum entanglement, Heisenberg uncertainty, and the like are all established physical phenomena, despite being incredibly weird and unintuitive. It's also unintuitive that space itself can expand, right, without there being some larger container space within which it expands. And it's intuitive that the placebo treatments can work even if you know that they're placebo. That's an established phenomenon, and so on ad nauseum. But of course, we clearly shouldn't conclude that all of these things are impossible just from their being unintuitive. In fact, we know that they're actual. Also unintuitive are Christian doctrines like Trinitarianism and the Incarnation. Should we conclude, Craig, that Christianity is impossible?
Thanks, Phil. That's you know, I know what you're doing right now, and I don't like it. So why don't you just shut your trap before I put my foot in it?
Furthermore, it's not at all clear why we should expect our intuitions about the properties of infinite sets to be a good guide to truth. And this is a point that I was making earlier in the video. This is because our intuitions have been cultivated and shaped by interaction only with finite quantities and collections. Just as we shouldn't expect our intuitions about quantum phenomena to be good guides to truth in quantum mechanics, precisely because the quantum realm behaves quite differently from the macroscopic realm in which our intuitions were cultivated, perhaps we likewise shouldn't treat our intuitions about infinite sets to be good guides to truth, precisely because infinity behaves quite differently from the finite quantities and collections around which our intuitions were cultivated. By the way, I'm also not alone in not finding the properties of infinite collections unintuitive. Or if they are unintuitive, I'm not alone in taking this to provide no good reason for thinking infinite collections are impossible. From theists to atheists to agnostics, I'm in quite good company. As theist philosopher Jacobus Erasmus points out, many mathematicians and philosophers don't share the relevant intuitions. Philosopher Blake McAllister likewise notes that if Craig's thought experiments do not seem intuitively absurd to an individual, as seems to be the case with many philosophers, then he has not offered any independent reason for why that individual should believe the situation to be absurd. It seems reasonable to assume that someone familiar with the branch of transfinite mathematics could view Craig's thought experiments as merely drawing out intriguing implications of actual infinites in the real world. The argument issues no epistemic obligation to those for which the quote-unquote absurdities are not intuitively evident. The argument issues no epistemic obligation to those for which the quote-unquote absurdities are not intuitively evident, and it appears that the number of people to which this applies is significantly higher than Craig would like. Take, for instance, Wes Morstan, who writes, I myself am inclined to side with those who say that the properties of the infinite are simply different from those of the finite, and that it is a mistake to assume that what's true of a finite collection must be true of any collection. Prominent theists are in the same boat as well. Alexander Proust, right, one of the most adept theistic philosophers alive, and a defender of the new Kalam, based on causal finitism, writes that I have a really hard time accepting the corollary that Hilbert's Hotel couldn't exist. That corollary seems extremely counterintuitive to me. This is a quote from Alexander Proust. I'm going to take you actually to the post where he says this. So here it is. He says, I still have to confess. So this is Alexander Proust's blog. I still have to confess that I have a really hard time accepting the corollary that Hilbert's Hotel couldn't exist. And that strikes him as extreme, not just counterintuitive, but extremely counterintuitive. So maybe the reason Alexander Proust finds the properties of actually infinite collections obviously intuitively benign, and in fact, he finds it extremely intuitive that actual infinites are possible. You know, maybe the reason why that's true for Alexander Proust and for me and for Wes Morstan and all these other philosophers and indeed theologians and lay people and so on, maybe it's because we're suppressing the truth and unrighteousness. You know, we just don't want Christianity to be true. Wait, Alexander Proust he's a theist. He's a Christian theist. He's a Catholic. Well, maybe that's the reason. It's those Catholics. No, but in all seriousness, this isn't us just trying to avoid theism or anything like that. We just don't share the relevant intuitions. And, if you want to make those sorts of allegations, I have some other allegations up my sleeve. So Craig's claim that Hilbert's Hotel and other actual infinites cannot exist is actually extremely counterintuitive for Proust. Like me, Proust intuitively finds Hilbert's Hotel and actual infinites to be obviously not absurd. And still other philosophers are in this boat as well.
It has to be said that in our paper, we were just assuming for the sake of argument that a Hilbert's Hotel is impossible.
Yeah. But you don't actually agree with that, right? But either of you?
I think it's just a very weird hotel.
Yeah, I think that it might be possible. It's epistemically possible that it's metaphysically possible, and it's epistemically possible that it's metaphysically impossible. I just don't really know.
No idea. Well, it seems to me that space could have been infinite. In fact, it seems to me that space could have been Euclidean. If we're just talking metaphysical possibility and so on, what God could have created, it seems to me it could have been that space is infinite. And had it been, then it seems to me that there could have been a Hilbert's Hotel. And why do I think that? I don't know, just simple Euclidean intuitions, go up in a straight line. You don't ever bump up against the end. There's always more. I'm inclined to think there could have been a Hilbert's Hotel. Whether any of the various universes that may exist are such that there could be a Hilbert's Hotel in them, I don't know. But it does have these weird properties.
Yeah, so, I mean, one of the things I was interested in is this idea that an actually infinite number of things can't exist, that in certain ways we're kind of granting for the sake of argument in the papers, and then still testing the argument in other ways, right? When I think about all of the times I've talked to philosophers about this question, it feels like hardly any philosopher is convinced by the absurdity of Hilbert's Hotel, that therefore it's impossible. I mean, it seems like when I have talked to philosophers, they have said, yeah, infinity is strange, but that's different than saying that it's impossible. And I was interested looking into, getting ready for this, I was looking at the new book by Proust, and he says, but while Hilbert's Hotel is indubitably strange, the strange and the absurd or impossible are different, as proved by the strangeness of the platypus. And then he goes on to say, he thinks there's a very strong reason to reject finitism and accept the possibility of something like Hilbert's Hotel. And so there's a book on infinity where the author thinks it's possible. And then I think Michael Humer's got a book on infinity where he thinks a Hilbert's Hotel is possible. Graham Oppie has a book on infinity where he thinks the Hilbert's Hotel is possible. But it seems like Craig and Locke, for example, have kind of a certainty that this is impossible, and all these experts are just completely wrong. And I mean, in Locke's version of it, it goes to a bit of an extreme because he thinks, because it's in a deductive argument, you can get certainty that the conclusion is true through the argument. But I mean, that would be the case if you're certain that it's sound. But I mean, the fact that so many experts on metaphysics and infinity seem to just disagree with that premise should cast some doubt on whether that's actually true.
So, by the way, that was a wonderful discussion. That's actually in my Kalam playlist. Those are three philosophers. That was Landon Hedrick, that was Wes Morstan, and that was Alex Malpass, all of whose work I'm going to be citing in this video. And for what it's worth, as Landon was pointing out in there, when he's talked with philosophers about this, almost none of them find it convincing at all. And the same is true with me in my experience talking with philosophers. Very few philosophers fall into the camp of both thinking that these are unintuitive or counterintuitive and thinks that gives us good reason for thinking that it's impossible. So, in short, the argument is powerless if you, like countless others, both theists and atheists alike, don't share the relevant intuitions. And even if you do, this doesn't warrant thinking actual infinites are impossible. Let's move on then to my fifth response, hasty generalization. That is to say. So the fifth response is that the alleged absurdities of Hilbert's Hotel rely on being able to manipulate, shift around, add, and remove hotel guests. But this is crucially disanalogous to an infinite past. You can't change or manipulate the past. It's over and done with. It's fixed. And what this means is that Craig has made a hasty generalization. Even granting him that Hilbert's Hotel is absurd and that it's impossible, its absurdity doesn't generalize to absolutely every infinite collection. Consider what Craig says on behalf of the generalization. If an actually infinite number of things could exist, they could be numbered and manipulated just like the guests in Hilbert's hotel. Since nothing hangs on the illustrations involving a hotel, the metaphysical absurdity is plausibly attributed to the existence of an actual infinite. As we've just seen, however, this is just flatly false. Some infinite collections may not be manipulable in the way the hotel guests are, which in turn would serve as a relevant difference that prevents us from justifiably inferring the impossibility of all actual infinites from the impossibility of Hilbert's hotel. As Wes Morrison writes, the supposed absurdities of a Hilbert's hotel do not follow merely from its infinity, but rather from what happens when infinity is combined with other features of this imaginary hotel. If the guests could not be moved, they could not be moved to other rooms in such a way as to make room for new guests. Nor would we have to worry about how many guests would remain when different actual infinities of guests have left the hotel. It is not at all clear, then, that Craig is entitled to conclude that no actual infinite whatsoever is possible. To see this, notice that mathematical objects, if there are such, are not movable. So the allegedly absurd implications of a Hilbert's hotel do not afflict infinite collections of them. More importantly for our purposes, past events are not movable. Unlike the guests in a hotel who can leave their rooms, past events are absolutely inseparable from their respective temporal locations. Once an event has occurred at a particular time, it can't be quote-unquote moved to some other time. Now, it should be noted that this is only a response to the first three allegedly absurd aspects of Hilbert's hotel that we articulated earlier, since only those involved manipulations. This response won't address Galileo's paradox, since it's still going to be true that the infinite set of past days can be put in one-to-one correspondence with infinitely many of its proper subsets. But, of course, I've already addressed the Galileo's paradox, and it utterly fails, so let's just continue. Now, defenders of the Kalam have replied to this hasty generalization point in at least three ways, and I'll consider each reply in turn. The first reply is that even if we can't manipulate past events, we can still imagine manipulating them, and this alone is sufficient to generate the relevant absurdities. Thus, Craig writes, let's suppose Hilbert's hotel is a hotel where, say, all the rooms are locked so that people can't move out of them. You can still imagine what it would be like for a person in room 1 to be in room 2, and the person in room 2, he could be in room 4, and you will generate the same absurdity. But there are several problems with this reply. First, one of the central absurdities was precisely that while you can debar infinite operations in the mathematical realm, there's nothing preventing the relevant inverse operations being tangibly performed in concrete reality.
Now, someone might say, but you can't do inverse operations with mathematical quantities. Not on paper, perhaps. But there's no way you can stop people from checking out of a real hotel. If you try to bar the door, they'll go out the windows. So this illustrates the absurdity of the real existence of an actually infinite number of things.
So again, one of the central absurdities here was precisely that while you can debar these sorts of operations in the mathematical realm, there's nothing preventing the relevant inverse operations like literally being tangibly performed in concrete reality, right? Remember the original video that I played at the beginning of this whole thing? Craig was asking us to really imagine a flesh and bones person in the room. But in that case, then, appealing to imaginary manipulations is just flatly irrelevant. For in the case of the real concrete past that actually occurred, there actually is something preventing the relevant inverse operations being performed. Namely, the fact that the past is fixed. Craig's response then just totally misses the mark. My second response to Craig's reply here is that once we transition to this purely imaginary version in which we're shuffling around and manipulating past events, what we're imagining, I think, is really an array of jointly existent things, namely past events, which are moved and shuffled around together. But granting for the sake of argument the quote-unquote absurdity of such manipulations of infinite collections, all we are then licensed to conclude is that an infinite collection of past events cannot all jointly exist together. Again, it was precisely because we imagined them as jointly existent that we were able to imaginatively take one and place it where another is, and to take that one and shuffle it around, and so on. But notice that this doesn't entail that the past can't be infinite, since we could instead conclude merely that it's impossible for past events to jointly exist. For instance, we could simply adopt presentism, according to which the only events that can jointly exist are present events. Indeed, Craig himself is a presentist. Landon Hedrick nicely articulates this second point in response to Craig's reply. It's true that the number of past events is the same as the number of even past events in Craig's scenario, but what is metaphysically absurd about this if the events don't exist? It still remains that the only conclusion we're able to draw from the absurdities that are generated from mentally numbering and then mentally shuffling past events is this: an infinite number of past events cannot exist. And as we've seen, the presentist is already on board with that, regardless of whether or not she thinks that an infinite number of them have occurred. Now, by the way, I'm not claiming that Landon Hedrick had my precise response here in mind, but what he makes there was actually what spawned me to think of this response. I don't claim that Landon's point in this passage here is numerically identical with the point that I made right here. It's just kind of what spawned me to make it. But anyway, he articulates a relevantly similar, I should put relevantly similar point in response to Craig's reply. So anyway, so yeah, that's the second reply. The third and final problem with Craig's response is that the same is true of an endless future. We can mentally manipulate and subtract future events from an endless future, leaving us with all the same alleged absurdities attending Hilbert's hotel. Alas, I'm going to table this endless future point for now, since I'm doing a deep dive on this point in my 7th response to the Hilbert's hotel argument. Okay, so remember, I said that defenders of the Kalam have replied to this hasty generalization point in at least 3 ways. I'm considering them in turn. So the first one was that we can still imagine manipulating the relevant past events. Even if we can't manipulate them, we can imagine manipulating them. And I don't think that works. That was one of Craig's replies. So that's the first one. Now let's move on to the second reply out of 3 to my hasty generalization point. So the second reply that proponents of the Kalam have offered to the hasty generalization problem is that even though we can't manipulate the past in the sense of taking past events and then moving them to different temporal locations, there is still a sense in which the past can be manipulated that's relevantly analogous to the manipulations in Hilbert's hotel. This is the sense in which the actual past could have been different, and that such differences can mirror the relevant removals and manipulations performed on the guests at Hilbert's hotel. To see this, suppose that the past is infinite, and suppose further that some indestructible counter has been counting down through all the natural numbers from eternity past, 1 number per year. Now, plausibly, the counter could have performed that count differently. For instance, it could have instead simply counted every even number, skipping all the years in which the counter would have otherwise counted all the odd numbers. In that case, there's a real sense in which, across these different possible worlds, infinitely many members of a collection have been removed. Similarly, that same counter likewise could have skipped counting down all the natural numbers except 3, 2, and 1. In a real sense, we again have removed infinitely many members of a collection across possible worlds. And notice what we've now accomplished, right? From a single collection, we've performed cross-world manipulations in which identical quantities are removed from identical quantities to yield collections with divergent quantities. And yet this was precisely what was absurd to Hilbert's hotel. Thus, even if we can't change the past, there's still a relevant sense of manipulation in which the absurdities afflicting Hilbert's hotel equally afflict an infinite past. To be sure, right, I've already responded to the point about subtracting infinite quantities from infinite quantities. It's not a good argument at all. But without relying on my earlier response to that argument, how could the proponent of the hasty generalization problem respond to this second reply? Well, I think there are at least 2 ways they can respond. First, they could try to pinpoint some relevant dissimilarity between manipulating things in the actual world on the one hand and performing quote-unquote manipulations on collections across worlds on the other hand, such that the alleged absurdities afflicting the former don't afflict the latter. Second, they can point out that all the same cross-world manipulations can similarly be performed on an endless future. For instance, imagine again that there's a counter, but this time the counter counts through each of the natural numbers throughout the span of an endless future. Each number will eventually be counted at some future point in time, and since there are infinitely many such natural numbers, we have here an infinite collection of future counting events spanning the endless future. But now just imagine that the counter skips every even number. In this case, each odd number will eventually be counted. And since there are infinitely many odd numbers, it follows that the cardinality of the collection of numbers, each of which will eventually be counted, is infinity, or Aleph null. Yet we remove from this collection each even number, and there are infinitely many of those. But now imagine, instead, that the counter simply counts 1, then 2, then 3, and then stops for the rest of endless eternity. Once more, we've removed infinitely many numbers from the count, and yet the resulting collection only has 3 members. Oh no, infinity minus infinity is both infinity and 3. Absurd. What we learn from this is that if the cross-world manipulations are indeed absurd, then an endless future is going to be just as absurd as the beginningless past. Not only is that monumentally implausible, since it seems obvious that the future could be endless, but you're also going to have to say goodbye to Christianity and Islam, since Christianity and Islam each posit an endless afterlife. So anyway, those are 2 replies to this second response on behalf of proponents of the Kalam to the hasty generalization problem. Now let's look at the third reply to the hasty generalization problem on behalf of proponents of the Kalam. This one is developed in Al-Ghazali, or Al-Ghazali if you're William Lane Craig, Andrew Locke, and several others. And this reply is that even if there's a relevant dissimilarity between an infinite past on the one hand and coexistent manipulable infinite collections on the other, the possibility of an infinite past actually entails the possibility of coexistent manipulable infinite collections. Hence, the absurdity of the latter implies the absurdity of the former. Here's how Al-Ghazali put it. Imagine that every day God creates an immortal human. If the universe has existed for an infinite number of days, then there would also be an infinite number of humans coexisting in reality. Thus, if it's impossible for an infinite collection to coexist, it's also impossible for an infinite temporal regress to exist. Andrew Loke puts things similarly. Suppose this is how Hilbert's hotel is constructed. There exists a hotel room builder who has been building hotel rooms at regular time intervals as long as time exists. Suppose there also exists a customer generator, which has been generating customers who checked in the hotel at regular time intervals as long as time exists. Suppose that the hotel rooms and the customers continue existing after they've been built and generated respectively. Now, if the actual world is one in which the universe is past eternal, then there would have been an actual infinite number of time intervals, and an actual infinite number of hotel rooms and customers occupying the rooms. The absurd situation which Craig describes would then happen if, for example, a new customer comes to the hotel asking for a place to stay when every room is already occupied. Now, again, I've already responded to these alleged absurdities, but let's just suppose for the sake of argument that they are absurd, and that coexistent actual infinite collections are all impossible. With all this in mind, and ignoring the customer generator for ease of exposition, the argument here that Locke and Al-Ghazali are offering is something like the following. 1. If the past could be infinite, then it could be the case that a unique hotel room is created on each day of the infinite past, while only finitely many such rooms are ever destroyed. 2. If it could be the case that a unique hotel room is created on each day of the infinite past, while only finitely many such rooms are ever destroyed, then a Hilbert's hotel is possible. 3. A Hilbert's hotel is not possible. So what follows from those is that the past cannot be infinite. Again, we're granting premise 3 here for the sake of argument, but what about premises 1 and 2? Well, premise 2 is obviously true, right? If a unique hotel room is built on each of the infinitely many past days, and if at most finitely many of those rooms are ever destroyed, well then clearly there will be infinitely many hotel rooms in the present. That is, there would be a Hilbert's hotel for all practical purposes. But what about premise 1 here, right? Why think that an infinite past's possibility entails the possibility that on each day of an infinite past, a unique hotel room is created, while only finitely many such rooms are ever destroyed? Well, you might think that a hotel room could be built on each of, say, 5 days of the past, if the past is infinite. Similarly, a hotel room could be built on each of 500 days of the past if the past is infinite. And the same is true of 5 million, 5 quadrillion, 5 quintillion, indeed possibly any number, including an infinite number. Moreover, there's no specific day of the infinite past on which the construction of a hotel is simply impossible. And what this means is that each day of the infinite past is such that a hotel room is possibly built on that day. And one might think that we can infer from this that it's possible that on all days of the infinite past, a hotel room is built. Moreover, nothing forces infinitely many such rooms to be destroyed, and so it also seems possible for only finitely many of them to have ever been destroyed. If all this is right, then premise 1 is secured. Nevertheless, I don't think this argument succeeds, and there are 3 primary reasons for this. First, premise 1 is seriously undermotivated and arguably false. So recall premise 1, right? Premise 1 is that link between the possibility of an infinite past and the possibility that on each day of the infinite past, a unique hotel room is created on that day, while only finitely many such hotel rooms are ever destroyed, right? So recall premise 1 more precisely. It says that if the past could be infinite, then it could be the case that a unique hotel room is created on each day in the infinite past, while only finitely many such rooms are ever destroyed. Now, the motivation we considered earlier was that because for each day of the infinite past, a hotel room could be built on that day, it plausibly follows that it's possible that on all days of the infinite past, one hotel room is built on that day. But this, of course, is clearly a non sequitur, right? From the fact that each member of a collection possibly has some property, it doesn't follow that it's possible that all the members of the collection have the property, right? Consider, for each day of the week, it's possible that I was born on that day, right? It's possible that I was born on Monday. It's possible that I was born on Tuesday, and so on for each day of the week. But it's obviously not possible that I was born on all the days of the week. That is, it's not possible for me to be born on all of them, all of Monday and Tuesday and Wednesday and so on, right? That doesn't make any sense. It doesn't make any sense for me to be born on both Monday and Tuesday and Wednesday and Thursday and so on. So it's not possible for me to be born on all of the days of the week. So even though each of the days of the week is such that it's possible for me to be born on that day, it's not possible for me to be born on all the days of the week. Similarly, from the fact that on each day of the past, it's possible for a hotel room to be built on that day, it doesn't follow that it's possible for all the days of the past to have a hotel room built that day. And actually, by the way, this is a formal logical fallacy. It's a formal logical fallacy to try to infer from a construction involving a wide scope universal quantifier, so a universal quantifier all the way to the left, followed by a diamond, a possibility operator, to try to infer from that a corresponding claim where those two are switched, where the possibility operator is in wide scope, so it's all the way to the left, and then the universal quantifier is right next to it on the right. So that's actually a formally invalid inference. That's just for the logic geeks that I made that point. Okay, so if you didn't understand that point, don't worry, right? Just return to the case of me being born on each day of the week. Even though for each day of the week it's possible that I was born on that day, it doesn't follow that it's possible that I was born on all the days of the week. Now, to make things simple, let's suppose that the hotel room builder is an omnipotent God. Now, omnipotence doesn't mean completely unrestricted power, right? It doesn't mean God can do literally anything. For instance, basically everyone agrees that God can't do what's metaphysically impossible. With this in mind, consider the following two claims. So here's the first claim, here's the second claim. The first claim we're going to call Formula A. For each natural number n, it is possible that God makes a hotel with n many rooms in total. And then Formula B. It is possible that God makes a hotel so big that there is a hotel room for every natural number n. Now, defenders of the Hilbert hotel argument will say that while Formula A is true, Formula B is false, right? For any natural number n, God could make a hotel such that the hotel rooms are numbered 1 to n, but he could not make a hotel where every single natural number corresponds to a unique room. The latter, but not the former, would involve creating a Hilbert's hotel, which we're assuming is simply impossible. As Malpass and Morriston write, we can put this general lesson in slogan form. For the defender of the Hilbert's hotel argument, each is possible, but not all. With this lesson in hand, a problem for premise 1 arises, right? Even if there's an infinite number of past events, such that at each of them God could have made a persistent hotel room, so long as his omnipotence is restricted to what's metaphysically possible, it doesn't follow that a Hilbert's hotel is thereby metaphysically possible. A hotel room builder with restricted omnipotence has the ability to spend any finite number of those pastimes creating hotel rooms, that is corresponding to Formula A, but not the ability to devote every one of an infinite number of pastimes to creating hotel rooms, which corresponds to Formula B. That is, a builder with restricted omnipotence could make it the case that the totality of past room creation events is numbered from 1 to n for any natural number n, but not that there is a unique past room creation event for every natural number n. To insist that the builder have the ability to do the latter is precisely to insist on violating the restriction on omnipotence to what's metaphysically possible. So then premise 1 is false, or at least it's unmotivated. Sure, for each natural number n, a builder can spend n many past days creating one hotel room per day, but it clearly doesn't follow from this that a builder can spend infinitely many past days creating one hotel room per day, right? A builder can spend any finite number of past days creating one hotel room per day, but it doesn't follow from that a builder can spend infinitely many past days creating one hotel room per day. And indeed, if, as we are assuming, a Hilbert's hotel is impossible, this latter ability isn't even a possible ability to have to begin with. In fact, not even an omnipotent being could do the latter, since it would entail the ability to make a Hilbert's hotel, which we are assuming is impossible. Now, one might object that this response is misguided, since there would be nothing to prevent the hotel room builder, in this case God, from spending each and every day of an infinite past constructing one hotel room per day. Locke expresses a version of this thought as follows. So Locke says, God cannot build a Hilbert's hotel at one go because the metaphysical impossibility of Hilbert's hotel would act as a constraint to prevent him from doing that. However, can God build one room at a time? Sure he can. There is nothing that could prevent God from building a persistent room at t-1, and nothing that could prevent God from building a persistent room at t-2, and nothing that could prevent God from building a persistent room at t-3, etc. Locke continues. The two examples, that is creating a Hilbert's hotel instantly and over time, respectively, are not equivalent in a crucial way, right? There's a relevant difference between them. One involves at one go, right, creating a Hilbert's hotel all in one go, whereas the other involves a process of building a hotel up over time. This makes a difference because to prevent someone from doing something, the prevention has to happen before or at the instant of action. However, after the person has acted, he can't be prevented from acting because what has been done has already been done. What this implies is that later conditions cannot prevent earlier conditions from happening. But alas, this response is mistaken. Sure, nothing prevents God from taking any individual step along the process, But something most certainly does prevent God from taking each and every one of the infinitely many steps along the process. And furthermore, this is always eternally and necessarily true. This prevention is always in force, since taking each and every one of the infinitely many steps is impossible at all times and in all circumstances, right? It's similar to how nothing prevents me from being born on any individual day of the week, right? Nothing prevents me from being born on Monday. Nothing prevents me from being born on Tuesday. Nothing prevents me from being born on Wednesday, and so on for each individual day of the week. But something most certainly does prevent me from being born on each and every day of the week. In particular, that's just metaphysically impossible, right? It can't happen. Moreover, we don't have any retroactive prevention going on here, right? The metaphysical impossibility of God taking each and every one of the steps along the process prevents it from ever being the case that God undertakes this task. And this prevention is always in force, even from eternity past. By the way, here's how Malpass and Morrison themselves respond to Locke. And I don't know why the font is acting up this way, but, it's kind of interesting. Gives it a little pop, doesn't it? So again, here's how Malpass and Morrison respond to Locke. What prevents God from adding hotel rooms one at a time and arriving at a Hilbert's hotel is that this is already a metaphysically impossible situation. Locke's suggestion, which painted the picture as if it required some spooky backwards in time influence from later conditions on earlier events, is in fact a straw man. If at t-1, God creates a single room, and then later at t0 there is a Hilbert's hotel, it follows that there already was a Hilbert's hotel at t-1. After all, the addition of one hotel room, or any finite number of hotel rooms, cannot ever be enough to change a finite hotel into an infinite one. So, if there is a Hilbert's hotel present now, then at every previous time, whenever God was adding hotel rooms, he was adding them to a Hilbert's hotel. But adding a room to a Hilbert's hotel is metaphysically impossible, just because the existence of a Hilbert's hotel, as we are assuming, is itself metaphysically impossible. The mistaken presupposition in Locke's response here is that we ever need to appeal to later conditions in order to rule out the earlier events in this scenario. If there is a Hilbert's hotel at any time, then each previous room building event is co-present with a Hilbert's hotel. And so there's really no retroactive preventative force going on here. The relevant metaphysical impossibility of God performing each and every one of the steps is always timelessly and eternally operative. So because of all the preceding, premise 1 is simply unmotivated. And that concludes my first response to this Locke-al-Ghazali argument. But the Locke-al-Ghazali argument also faces other challenges, which is my second response. For instance, it could easily be the case that infinite pasts simply always and essentially contain only a finite number of things. I see no reason whatsoever to rule this out, and yet ruling it out is required in order to justify premise 1. For if infinite pasts always and essentially contain only finitely many things, then it's simply impossible for anyone to construct a Hilbert's hotel over the span of an infinite past, right? That would clearly require there to be some time at which infinitely many things exist. Yet another challenge for premise 1 is developed in philosopher Landon Hendrick's article Once More to the Hotel. So again, premise 1 says if the past could be infinite, then it could be the case that a unique hotel room is created on each day in the infinite past, while only finitely many such rooms are ever destroyed. So Hendrick writes, consider this hotel room builder steadily constructing room after room. Does the builder have an infinite supply of materials or a finite supply? Since we are already assuming that an actually infinite number of things cannot exist, we need to imagine that the builder only has a finite supply of materials. Having only a finite supply of materials to work with, the builder can only construct a finite number of hotel rooms before running out of materials. And since we are supposing that the entire world consists of only a finite number of things, the builder would only be able to build a finite number of hotel rooms, even if it used all of the contents in the world as its construction materials. Eventually, the builder would only be able to add on new rooms by tearing down old rooms and reusing the materials. But then, at no point would an infinite hotel exist, even if past eternalism were true. And that is, even if the past were infinite in duration. And what this shows is that the possibility of an infinite past, by itself, doesn't at all entail the possible existence of coexistent infinite collections. Now, one way to get around this, of course, is to add that the hotel builder can create new materials ex nihilo. So when the builder runs out of materials, it simply says the magic words and poof, new materials pop into existence. But then the possibility of Hilbert's hotel doesn't follow just from the possibility of an infinite past, right? You need auxiliary assumptions. They need to be added. As Hendrick writes, once the details of Locke's thought experiment are spelled out, we see that he can derive the conclusion that the conjunction of past eternalism and these auxiliary assumptions is impossible. But of course, it doesn't follow from this that past eternalism is impossible, or even that past eternalism is false. To infer, then, that an infinite past is impossible from the argument under consideration, we would need to show that creation ex nihilo is possible. But that is an exceedingly difficult task. Not only does creation ex nihilo seem absurd to many, but it's also going to be difficult to establish its possibility without antecedently assuming the very question at issue in the Kalam debate, namely, God's existence. And that concludes my second response to the Lok al-Ghazali argument. So here's my third response to the Lok al-Ghazali argument. It's that a symmetric argument would just as easily prove that the future cannot be endless. Just consider this symmetric argument. Premise 1 star. If the future could be endless, then it could be the case that a unique hotel room is destroyed on each day of the endless future, while only finitely many such rooms are ever created in such a future. 2 star, if it could be the case that a unique hotel room is destroyed on each day in the endless future, while only finitely many such rooms are ever created in such a future, then a Hilbert's hotel is possible. Premise 3 star, a Hilbert's hotel is not possible, and so conclusion, the future cannot be endless. And of course, you can witness the symmetry here. All the words are exactly the same. You're just basically replacing past with future. You're replacing created with destroyed in each instance. And instead of saying the past is beginningless, you say the future is endless. Or instead of saying the past is infinite, you say the future is endless. Okay, so that's the symmetry, quite obvious symmetry between them. So premises 3 and 3 star are identical, as you can see. And like premise 2, right, premise 2 star is clearly true. I mean, I hope you can kind of just see that intuitively. I'm going to go through a demonstration here, just in case you can't see it intuitively. If you're destroying a unique hotel room on each day of the endless future, and you're only ever constructing finitely many such hotel rooms throughout the endless future, then there's going to be a Hilbert's hotel in the present, because you need infinitely many rooms to be able to destroy a unique room on each day of the endless future, while only building finitely many such rooms. So anyway, I hope you can kind of see that 2 star is intuitively true, but for those of you who don't kind of see that intuition directly, I'm going to give you a kind of demonstration here. So this is going to be a kind of technical demonstration. You're going to have to bear with me for this long paragraph, but I'm just demonstrating that 2 star here is true. Okay, so suppose that Hilbert's hotel is impossible. I'm supposing that the consequent here is false, and then I'm going to derive the falsity of the antecedent, right? In which case, that'll show that the falsity of the consequent implies the falsity of the antecedent, which is just another way of saying by contraposition that 2 star is true, right? That would mean that the truth of the antecedent entails the truth of the consequent. Okay, so we're going to suppose that Hilbert's hotel is not possible. So then at any given time, t, in any possible world, there are only finitely many hotel rooms at t. And we can now ask, could it be the case that a unique hotel room is destroyed on each day in t's endless future, while only finitely many such rooms are ever created in t's future? Well, clearly not. Recall that there are only finitely many rooms at time t. Furthermore, we've assumed that only finitely many more hotel rooms will be built in t's future. But then a unique hotel room won't be destroyed on each day of t's endless future. For if only finitely many hotel rooms exist at time t, and only finitely many more hotel rooms will be built in t's future, then at some future time t star later than t, it will be true that 1, no more hotel rooms will be built, and yet 2, only finitely many hotel rooms exist. But then after t star, clearly only finitely many hotel rooms can be destroyed. After all, only finitely many exist, none more will be built, and you can only destroy what already exists. So, since only finitely many hotel rooms can be destroyed after t star, and since a unique room is being destroyed per day, it follows that the destruction of rooms is going to come to an end after some finite number of days. But, of course, then it's false that a unique hotel room is destroyed on each day in t's endless future. That would require the destruction of rooms not to come to an end, contrary to what we've just concluded. Hence, by assuming the impossibility of a Hilbert's hotel, we concluded that it couldn't be the case that a unique hotel room is destroyed on each day in the endless future, while only finitely many such rooms are ever created in the future. Hence, if it could be the case that a unique hotel room is destroyed on each day in the endless future, while only finitely many such rooms are ever created in the future, it follows that a Hilbert's hotel is possible. And that is just a statement of premise 2 star, right? So if you look at this, that is just a statement of premise 2 star. So sorry that was a technical derivation, but it was for those of you who weren't kind of able to intuitively see 2 star. But I hope most of you are kind of able to see kind of just intuitively 2 star's truth. Finally, then, we ask about premise 1 star. Well, I say it seems entirely symmetrical to premise 1, right? Any reason favoring premise 1, it seems, would equally favor premise 1 star. And in that case, there's no principled way to accept premise 1 while rejecting premise 1 star. I've already criticized the reasons offered on behalf of premise 1, but what matters for present purposes is that those reasons would, if successful, equally support premise 1 star. A unique hotel room could be destroyed on each of, say, 5 days of the future if the future is endless. Similarly, a hotel room could be destroyed on each of 500 days of the future if the future is endless. The same is true of 5 million, 5 quadrillion, 5 quintillion, indeed plausibly any number, including an infinite number. And if you're paying attention, this is basically the exact same motivation that I discussed. And I'm just altering the wording ever so slightly. This is the exact same motivation I discussed in the context of premise 1. Moreover, there's no specific day of the endless future on which the destruction of a hotel room is simply impossible. And what this means is that each day of the endless future is such that a hotel room is possibly destroyed on that day. And one might think that we can infer from this that it's possible that on all days of the endless future, a hotel room is destroyed. Moreover, nothing, of course, forces infinitely many such rooms to ever be created, and so it also seems possible for only finitely many of them to ever be created. And if all this is right, then premise 1 star is secured. Again, I've already criticized this sort of reasoning. It fails, it doesn't work, but my point is just that if it supports premise 1, then it equally supports premise 1 star. So, I've argued that anyone who accepts the first argument should also accept the second. That is, anyone who accepts the Loc al-Ghazali argument as applied to an infinite past should also accept the second symmetrical argument as applied to an endless future. But we might ask, why does this matter, right? Like, what's so bad about accepting the second argument? Well, for starters, its conclusion seems obviously false, right? It seems obvious that the future could, in principle, be endless. And furthermore, its conclusion entails that Christianity, Islam, and other religions that promise an endless afterlife are not just false, but impossible. So we got, by the way, Christianity is false, TM. Put that on a shirt and sell, thousands of them. Anyway, that caps off my fifth response to the Hilbert's Hotel argument. And now we are on to my sixth and favorite response. So we're getting into this, by the way, Christianity is false territory. So yes, on to that. What if I told you that William Lane Craig has implicitly disproved Christianity? Well, you might not believe me, but it's actually true. If Craig's Hilbert's Hotel argument succeeds, then Christianity is false. And my task in this part of the video is to explain why. So recall the Hilbert's Hotel argument. 1, an actual infinite cannot exist. 2, an infinite temporal regress of events is an actual infinite. 3, therefore, an infinite temporal regress of events cannot exist. The problem is that there's an equally strong symmetrical argument, or at least equally weak symmetric argument, as the case may be. So yeah, it goes premise 1, an actual infinite cannot exist. That's the same as up here. Premise 2, an infinite temporal progress of events is an actual infinite. And so an infinite temporal progress of events cannot exist. You're just replacing a regress with progress. And since an endless future just is an infinite temporal progress of events, that is, one event following another, and another following that, and another following that, and so on ad infinitum, it follows that an endless future cannot exist. To make things simple, let's just put the symmetrical argument as follows. 1, an actual infinite cannot exist. 2, an endless future is an actual infinite. 3, so an endless future cannot exist. Recall that an actual infinite is just a collection with infinitely many members. That is, it's a collection that can be put in one-to-one correspondence with the natural numbers. This, in turn, means that the collection has Cantor's property, where the whole collection can be put in one-to-one correspondence with some, indeed infinitely many, of its proper sub-collections, or its proper subsets. Okay, so I guess we are witnessing here a near-death experience where Craig's soul is leaving Craig's body here. Okay, but anyway, let's play the video.
Technically speaking, what defines a collection or a set as actually infinite is that it has a proper part which has the same number of members as the whole collection. It has a proper part with the same number of members as the whole collection.
So that's an actual infinite. By contrast, a potential infinite is a collection that's always finite and always growing without limit or without bound. With these definitions in hand, you might be tempted to make a natural objection to the symmetry argument, this symmetry argument up here. The objection is that an endless future is merely a potential infinite, not an actual infinite, whereas a beginningless past is an actual infinite rather than a potential infinite. If this is right, then premise 2 of this symmetric argument is false. It's worth noting that proponents of the Kalam typically hold that past, present, and future tenses pick out real, irreducible, objective, or mind-independent features of reality, and that temporal becoming or the flow of time is similarly real and objective. Thus, they typically hold that there's an ever-changing fact of the matter about which events are present, and an equally objective fact about the direction of temporal becoming, or flow. On this sort of view, there's a clear difference between a beginningless past and an endless future. The former has been completed, whereas the latter will never have been completed. From this, defenders of the Kalam conclude that an endless future is only potentially infinite. As Craig writes, when we say that the number of future events is infinite, we do not mean that Aleph Null many events will elapse, for that is false. Ironically, then, it turns out that the series of future events cannot be actually infinite regardless of the infinity of the past or the metaphysical possibility of an actual infinite, for it is the objectivity of temporal becoming that makes the future potentially infinite only. Craig reiterates this line of thought time.
If you think about the number of events in the future as like equivalent to the number of guests in the hotel, and then as time passes, we're removing an event from the future and putting it in the present. And we can ask how many events are there left in the future. It's the same number of events in the future as there were before that event entered the present. So even though we've taken one away, we've got the same number left. And that's exactly the same property. It's adding one guest and having the same number of guests after adding it in. So if one of them is problematic, so is the other.
If the idea of infinity is putting pressure on the idea of an infinite past, then it's going to put equal pressure on the idea of an infinite future. There's no clear asymmetry there that means that one of those is problematical in a way in which the other isn't.
Well, there is a notable asymmetry between the past and the future given a tensed theory of time, according to which temporal becoming is an objective feature of reality. On this view, the past is now actual, but the future is merely potential. Moore seems to be presupposing a tenseless theory of time, according to which past and future are on an ontological par.
It seems to me that this rests on a mistake, because Craig, instead of focusing on the question, how many future events will there be if the future is endless, to which the answer is infinitely many, Craig instead switches to how many future events will have been. And that, it's true, is always finite and increasing over time and approaching infinity but never getting there. But its problem is that those two things are compatible with each other. And for one thing, it's changing the subject. If you say how many events will there be, and to answer in terms of how many events there will have been, it's changing the subject. But also, they're both true. I mean, even though there will have been finitely many events, it's also true that there will be infinitely many events. I mean, in the infinite future, those two are not incompatible with each other.
No, I just disagree with Alex here. There will never be an actually infinite number of events. For any finite number you pick, there will eventually be that many events, but there will never be an actually infinite number of events. You can't turn a potential infinite into an actual infinite by counting.
So as I'm about to explain, though, this is thoroughly confused and it's painfully mistaken. An endless future is an actual infinite, and Craig is flatly mistaken to say that it's false that infinitely many events will elapse. Following Malpass and Morstan in their 2020 article, Endless and Infinite, let's represent the potential infinite and the actual infinite using functions. A function is just a rule that defines a relationship between inputs and outputs. It's basically something that takes input values and performs some operation on them to deliver output values. Because a potential infinite involves the dynamic idea of increasing over time, we can represent it using a function, p of x, whose output increases as the input increases. So let's take the natural numbers in their usual ordering, 1, 2, 3, 4, and so on. And again, some definitions begin the natural numbers with 1 and others with 0, but just set that aside. So again, we're taking natural numbers in their usual ordering, and we're going to let them stand for distinct successive intervals of time. Now we're going to let p of x be a function that takes natural numbers as its input, that is, as values of the x variable, and returns as output the set of all the natural numbers less than or equal to the input. So the output of the function p of x can be represented as the set of all natural numbers n, such that n is less than or equal to x. So let's test our understanding. So p of 2 is going to be the set containing 1 and 2, right? Because remember, the output, whenever you plug in some x value as the input, the output is just the set of all the natural numbers less than or equal to that input, right? So p of 2 is going to be the set containing 1 and 2. P of 5 is going to be the set containing 1, 2, 3, 4, 5. P of 10 is going to be the set containing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now, notice two important facts about the function p of x. First, as the value of x increases, the cardinality of p of x's output similarly increases, right? If x equals 2, the cardinality of p of 2 is the cardinality of the set containing 1 and 2, which of course is 2, or has 2 members. So the cardinality of that set is 2. If x equals 5, The cardinality of P of 5 is the cardinality of the set containing 1, 2, 3, 4, 5, which is 5, and so on. So as the value of x increases, the cardinality of P of x's output similarly increases. The second thing to notice about the function P of x is that for all values of x, the cardinality of P of x is finite. This is because for each value of x you pick from among the natural numbers, the cardinality of P of x just is that natural number x. Thus, the cardinality of P of x is always finite, no matter what the value of x is. So again, if you plug x equals 5 in, the cardinality of P of 5 is itself 5, and so on. So the cardinality of P of x is always finite, no matter what value of x you plug in. And so what this means is that P of x is a function that captures the notion of a potential infinite. The cardinality of P of x's output is always finite, but always increasing as its input value increases. Moreover, this cardinality has no limit. Since the input value x can be any arbitrarily high natural number, the cardinality of P of x can likewise be any arbitrarily high natural number. So, as x increases without limit, so does the cardinality of P of x. The function P of x therefore represents a potential infinite. As the input increases, which represents the passage of time, the output is always finite and always increasing without limit. So P of x represents the potential infinite. But now consider a different function, A of x. P, if you haven't noticed, stands for potential, and A stands for actual, right? Bada bing, bada boom. Things are connecting. The puzzle pieces are falling together. Okay, so now consider a different function, A of x. This function takes any natural number x as input and outputs the set of all natural numbers greater than x, right? So whereas P of x outputted the set of all natural numbers less than or equal to x, the function A of x outputs the set of all natural numbers greater than x. So the output of the function A of x can be represented as the set of all natural numbers n, such that n is greater than x. So to test comprehension, we have A of 2 equals the set containing 3, 4, 5, 6, 7, 8, 9, 10, and so on ad infinitum. A of 5 is going to be the set containing 6, 7, 8, 9, 10, and so on. And A of 10 is going to be the set containing 11, 12, 13, 14, and so on. Because remember, the output is the set of all the natural numbers greater than the input value. Now, notice two important facts about the function A of x. First, as the value of x increases, the cardinality of A of x's output does not increase. If x equals 2, the cardinality of A of 2 is the cardinality of the set of numbers greater than 2, which is just Aleph null. And if x equals 5, the cardinality of A of 5 is the cardinality of the set of natural numbers greater than 5, which is also Aleph null, right? You can put those in a one-to-one correspondence with the natural numbers. In fact, for any input value of x, the cardinality of A of x is simply Aleph null. So, as the value of x increases, the cardinality of A of x's output does not increase. So, the second important fact about the function A of x is that for all values of x, the cardinality of A of x is actually infinite. As we just saw, whatever value of x you pick, the cardinality of A of x is just Aleph null. And in that case, A of x will have Cantor's property. The whole set can be put in one-to-one correspondence with many, indeed infinitely many, of its proper subsets. So, A of x always has infinitely many members. It is, in other words, an actual infinite. What this means is that A of x is a function that captures the notion of an actual infinite. The cardinality of A of x is always Aleph null. It's never finite, and it never increases as the input value increases. So the function of A of x therefore represents an actual infinite as opposed to a potential infinite. With all this in mind, we can now see why an endless future is an actual infinite. The basic reason is that an endless future is modeled by the function A of x, not P of x. And so let's take this step by step. So when Craig attempts to answer the question, how many future events will there be if the future is endless, his reply is potentially infinitely many. But Craig here faces a dilemma, as Malpass and Morstan point out in their paper, Endless and Infinite. Either what he says answers the right question but is false, or it's true but it answers a completely different question. Either way, it's not a satisfactory answer. So if Craig is actually answering the question at hand, then his response is simply false. The question at hand is how many future events will there be if the future is endless? As Malpass and Morstan point out, the number of events that will be is not a finite but ever-increasing number. For example, it's not as if today there will be, say, 10 future presidential inauguration events, but that tomorrow there will be 11. However many future presidents will be sworn in, that number can only go down as each new one gets sworn in. It certainly cannot increase as time passes. And given this truism, Craig's reply is just false. The argument here is simple. For the number of events that will occur to constitute a potential infinite, that number would have to be finite but always increasing as time progresses. But it's obviously false that the number of events that will occur increases as time progresses. If anything, it decreases, since as time progresses, events are removed from the future, become present, and recede into the past. It simply makes no sense whatsoever to suppose that the number of events that will occur increases as time goes on. But in that case, it's patently false to say that the number of events that will occur is potentially infinite, since that implies that the number does increase as time goes on. Hence, Craig's reply is simply false. How could Craig think otherwise? Well, Malpass and Morstan point out that he's subtly misunderstanding the question. They point out that we know what Craig means to express here. The trouble is that when you spell it out, we go down the second horn of the dilemma, and the answer doesn't address the original question. On the dynamic theory of time, it's not the future that is an ever-increasing number of events, but rather it is the past that is ever-increasing. Take, for instance, the Aristotelian idea that potentialities become actualized as time passes, an idea that has much in common with the growing block theory of time. According to this idea, as time passes, more and more events get added to the block of actual events, which quote-unquote grows. Events that are currently future and potential will have been added to the stock of events that have occurred. But notice that this is the output that the p of x function is giving us, right? If x is what time it currently is, then p of x is how many events have occurred up until the current time. But in that case, Craig simply isn't addressing the question, right? The question at hand is how many events will occur if the future is endless. It's asking for the cardinality of those events that will be. But when Craig answers potentially infinitely many, he's saying that as time passes, the number of events that will have been actualized increases without limit. So we have changed tense from simple future tense to the future perfect tense. Craig's answer is about what will have been as time goes on, rather than what will be, simpliciter. This change of tense represents a change of subject. His answer would be relevant only if the question were how many events will have been. But when we clarify that the question is how many events will there be, his answer is plainly not relevant. Just think about it. An endless future, that is, the collection of events later than the present, or the collection of events each of which will occur, is captured not by the p of x function, but instead by the a of x function. After all, the series of events later than any arbitrarily selected past event does not increase in number as time passes. We've already seen this. For instance, no matter how many inaugurations there will be later than some past event, that number cannot go up as time passes. But the p of x function does increase over time, right? As its input x value increases, which recall represents the forward progression of time, the cardinality of the output set likewise increases over time. But we just saw that the collection of events later than the present does not increase as time progresses. Hence, the collection of events later than the present does not correspond to the p of x function, and hence is not a potential infinite. Moreover, this is all just perfectly obvious upon reflection. After all, the series of events later than a given time is structurally identical to the series of numbers greater than a given number, which is precisely what the a of x function gives as its output. And if the future is endless, the structural identity with the natural numbers is even clearer, since the numbers greater than a given number likewise don't come to an end. Thus, since the cardinality of a of x is always actually infinite, and since an endless future is modeled by a of x rather than p of x, it follows that an endless future is an actual infinite. And notice that we're not merely talking about abstract mathematical infinity here, right? We're talking about concrete, tangible events that will, in fact, be realized. As I've explained, the number of such events is actually infinite. The reason Craig misses this point is that he's imagining the number of events between some fixed past event on the one hand and the moving now on the other. This number is indeed always finite and always increasing without limit. Right? So that is a potential infinite. So what Craig is imagining then is the following, and this is from Malpass and Morrison's paper, Endless and Infinite. Craig is picking some arbitrarily selected past event or even, the present event, and then he's looking at the number of events that have elapsed as the moving now increases with time, right? Now that will indeed always be finite, and it's always increasing, right? So that is indeed a potential infinite, right? As this moving now increases along the timeline, the distance, as it were, the temporal distance from this arbitrarily selected past event to the moving now is indeed always finite, and it's always increasing without bound. So that is a potential infinite. But notice that that's not the simple future tense when we're looking at it from the perspective of this past event here, right? That's looking at how many events will there have been as the moving now goes along, right? So how many events will there have been? It's like will there, that's the future, and then the perfect, have been. You're looking back and counting how many events have elapsed in between here and here. But that's not what we're asking when we're asking about how many events will there be. When you're asking about how many events will there be, you're not talking about how many events will there have been as the moving now progresses. So you're not talking about the distance between here and here. You're talking about how many events are in the future simpliciter. How many events will there be simpliciter? How many events are later than here? And if the future is endless, right, that includes not only from here to here, but includes all the way out. It includes this whole entire arrow. It includes the entire positive x-axis. And how many numbers are on that positive x-axis? Infinitely many. It's an actual infinite. There's no denying this. Craig rightly notices that the interval between that past event and the present is always finite, but always increasing with the passage of time, right? This is indeed what's potentially infinite. It remains finite, but it always increases as the moving now progresses forward. So again, Craig is referring to the ever-increasing interval between some fixed point in the past and the location of the moving now. But notice then that this is completely irrelevant to the original question. The original question concerns the entire future of a given point. We aren't asking about the interval of time between the point and the moving now as time progresses. We're talking about everything in the point's future, including everything that's beyond the moving now. Even though Craig has said the series of events later than any arbitrarily selected past event is properly to be regarded as potentially infinite, we have to take him to mean, otherwise he's just making just a schoolboy error, we have to take him to mean the series of events in the interval between an arbitrarily selected past event and the present is properly to be regarded as a potential infinite. As Malpass and Morstan note in this regard, it is right that this new phrase picks out an interval that is potentially infinite, but the problem is that it doesn't address the question of how many future events there will be. It addresses the gap between a past event and the moving present, which is just a complicated way of expressing the future perfect tense again. It is about how many future events will have been as time progresses. Thus, the reconstruction only succeeds in identifying something potentially infinite at the cost of not describing the future any longer. We're not describing the simple future, the future simpliciter. So, to put things as explicitly as possible, here's the rub. When we ask how many events will there be, we're asking about the number of events later than the present. This is quite obviously the a of x function, which takes an x value as input, which remember represents a time, and then outputs all the numbers greater than x, or all the times later than x. This is just like taking the present day as input and then outputting all the days later than the present day. We're not asking about how many days there will have been between today and the moving now, or how many days will have been completed between today and the moving now. Yes, these are potential infinites, but that wasn't the question. The question is posed in the simple future tense. How many events or days will occur? And if the future is endless, then aleph null many days will occur. This doesn't imply that there will ever come a time when infinitely many days have been completed, of course, just as the fact that there are aleph null many numbers greater than 5 doesn't imply that there's some number infinitely greater than 5. But this doesn't change the fact that each of infinitely many days is such that it will occur at some point in the endless future, just as each of infinitely many natural numbers is some finite distance from the number 5. The result is that an endless future is a collection with aleph null many elements. It involves aleph null many days, years, seconds, and events. Thus, it's an actual infinite, not a potential infinite. Now, you might think that presentism, the view that only present things and events exist, implies that the number of events, each of which will occur, is 0. After all, the future doesn't even exist under presentism, and so there are literally no events that will occur. The problem with this response, however, is twofold. First, the same is true of past events if presentism is true, and so the argument would cut both ways, right? It would likewise prove, if successful, that even if the past is beginningless, the number of past events is 0 rather than actually infinite. And so, with respect to that first argument that we considered, right, the non-symmetrical argument, this second premise would be false. An infinite temporal regress of events is an actual infinite. No, the infinite temporal regress of events, the number of members in that collection would be 0 according to this response. It's not actually infinite. It's not aleph null. So that's the first problem with that reply. But the second problem with that reply, and the more fundamental problem with it, is that even if future events don't yet exist, they nevertheless will exist, and we can obviously still count them. For instance, we can still count how many years there will be between 2022 and 2050, even if such years don't yet exist. This is all I need to make my case here. So long as we can count future events and days, we can count how many future events or days there will be in an endless future, and the answer to that is obviously actually infinite. You might also object that an endless future cannot be actually infinite, since future events are mere potentialities, whereas past events have been actualized. Future events, says Craig, have not as of yet been actualized, whereas past and present events have been actualized. Unlike past events, then, future events are pure potentialities and are not part of the actual world. Well, there are many serious problems with what Craig says here. On Craig's presentism, though, past events are also not part of the actual world, right? They don't actually exist, and so they clearly aren't part of the actual world. That is, what's actual. If past events don't exist, then they aren't part of anything, just as my non-existent third eyeball isn't one of my body parts, right? To be a part of something, you have to be there, right? To be a part, you have to be. But set that aside, because there's a deeper problem with this objection. In particular, whether future events are mere potentialities is completely irrelevant. All that matters for present purposes is the number of future events. So be it if those future events are mere potentialities. That's still no barrier to asking about their number. Potentialities that will be actualized are just as numerable as those that have been actualized. So you're just relocating the problem. We'll have an infinite collection of potentialities, and the number of those potentialities will be Aleph null, in which case it's an actually infinite collection. It's an actually infinite collection of potentialities. It's still an actually infinite collection, and it's going to inherit all those purported problems that Craig identifies with the actual infinite. It's going to have Cantor's property. It's going to have proper parts that are equinumerous with the whole, etc. So again, so be it if those future events are mere potentialities. That's no barrier at all to asking about their number. We can still number them. We can still count them. Potentialities that will be actualized are just as numerable as those that have been actualized. To see this, Malpass and Morrison ask us to consider two scenarios. In the first scenario, Counter will begin his count 1 minute from now. 1 minute after that, he will add 1 to his count. 2 minutes later, he will add 1 to his count. And after that, he will never do any more counting. We can, if we like, think of this as a series of potential counting events. We can then ask how many distinct counting events will ever be actualized. That is, we can ask for the number of potential counting events, each of which will be actualized by the counter at some time or other. And it would be absurd to say that the answer is anything other than 3. The counter is going to begin his count 1 minute from now, and then after that he's going to count another, and then after that he's going to count another. How many potential counting events will there be in this world? Obviously 3. That's the only sensible answer to this. So even if the counting events are mere potentialities, we can still count them. There's still a collection of them. The collection has a number. It's 3. So that's the first scenario. Now consider this second scenario, which involves an endless counter. Counter will begin counting 1 minute from now. 1 minute after that, and after every other future act of counting, he will add 1 to his count. Again, we can think of this as a series of pure potentialities, each of which will be actualized. And again, we can ask for the number of potential counting events that will, at some time or other, be actualized. It is easily proved by mathematical induction that for every positive integer n, counter will actualize an nth potential act of counting. Here, then, we have an infinity of potentialities, which, note well, is not to be confused with a potential infinity. A tensity of time, then, is utterly irrelevant to the number of future events if the future is endless. Even if those future events are pure potentialities, and even if they haven't yet been actualized, and even if there will never come a time at which it is true that all of them have been actualized, their number is still actually infinite. Again, think of the natural numbers. There's no natural number infinitely far away from the number 1. Each natural number instead is only finitely far from the number 1. There will never come a natural number of which it is true that infinitely many natural numbers are before it. Even still, the number of natural numbers greater than 1 is actually infinite. Similarly, there's no future point in time infinitely far away from the present. Each future day, instead, is only finitely far from the present. There will never come a future day of which it is true that infinitely many days later than today are before it. Even still, so long as the future is endless, the number of days later than today is actually infinite. There's no denying this. If you deny that, you're in denial of reality. And notice the significance of all this. What it means is that all the same allegedly absurd properties attending Hilbert's hotel likewise attend an endless future. Right? To see this, return to the endless counter scenario. Suppose this counter counts the number 1 tomorrow, the number 2 the next day, the number 3 the day after that, and so on ad infinitum, counting each natural number, 1 per day, throughout the endless future. This is entirely possible if the future is endless. Now, in this scenario, since each natural number will eventually be counted at some future time or other, and since there are infinitely many such numbers, it follows, deductively, that each of infinitely many numbers will be counted. But now suppose that the counter skips all the even numbers, opting instead to take a day off in between the days on which odd numbers are counted. Again, each odd number will eventually be counted at some point in the future, and since there are infinitely many odd numbers, it follows that each of infinitely many numbers will be counted. And yet we removed all the even-numbered counting events. So infinity minus infinity is infinity. Oh. But now suppose that the counter simply stops counting after counting up to 3. Once again, we've removed infinitely many counting events. In particular, we've removed the events of counting 4, 5, 6, and so on ad infinitum. And in this case, a finite number of counting events will transpire. So infinity minus infinity is 3. Row. We've subtracted identical quantities from identical quantities to yield divergent results. Absurd. So again, all the same absurdities that allegedly attend Hilbert's hotel and actual infinites more generally likewise attend an endless future. 3 other alleged absurdities attending Hilbert's hotel similarly attend an endless future. Galileo's paradox applies, since the whole set of future counting events can be put in one-to-one correspondence with a proper subset thereof. The whole set of future counting events involving counting each of the natural numbers can be put in one-to-one correspondence with the set of future counting events, which is just counting the even natural numbers. So there's a one-to-one correspondence between a whole set and one of its proper parts. And moreover, we can add and remove one or even infinitely many counting events to or from this series while the series retains the same number of members, namely Aleph null. So if these properties truly are absurd, then it follows that an endless future is impossible. What we learn from all the preceding is that the second premise of the symmetry argument is true. An endless future is an actual infinite. By my lights, this is just utterly undeniable. And to make things perfectly explicit, right, I am not claiming that there's some point in the future at which infinitely many events have occurred. Okay, just as I'm not claiming in saying that there are infinitely many numbers greater than one, I'm not claiming that there's some number infinitely distant from one, such that at the perspective of that number, there are infinitely many numbers before it, going back to one. No, you're not saying that. So again, I'm not saying that there's some point in the future at which infinitely many events have occurred. Instead, the claim is simply that each of infinitely many events will occur. That is, the number of events E, of which it is true that E will occur, is Aleph null. Now, if you're still not seeing why an endless future is an actual infinite, don't fret. Craig, after all, has been repeatedly corrected on this point, and he still doesn't seem to get it, but I'm here to help. In particular, I've collected 5 arguments that will hopefully help you see why an endless future is undeniably an actual infinite, that is, a collection whose members can be put in one-to-one correspondence with the natural numbers. Now, some of these arguments are similar to one another, and I don't claim that each is independent from all the rest. Their purpose is simply to help those who are struggling to see why an endless future is an actual infinite. Their purpose is pedagogical in nature. The first argument is one we've already seen, but it's useful making it explicit. Suppose there's an endless counter who counts a unique natural number per day of the endless future, beginning tomorrow with 1. Since each day is paired with a unique natural number that the counter will count, and vice versa, it follows that the number of days in an endless future is the same as the number of natural numbers the counter will count. But the number of natural numbers the counter will count is Aleph null, right? This is because each natural number will eventually be counted at some point or other in the endless future. That is, there's no number that the counter will fail to reach. So, since there are Aleph null many natural numbers, and since each natural number will eventually be counted by the counter, it follows that the number of natural numbers that the counter will count is Aleph null. Hence, since the number of days in an endless future is the same as that number, as I've already showed, it follows that the number of days in an endless future is likewise Aleph null. Hence, an endless future involves an actually infinite collection of days, in which case, the endless future is an actual infinite. The second argument is one we've also already seen, but again, it's useful to make it explicit. Note, though, that this argument is only meant to be a response to the objection that an endless future is a potential infinite. It's obviously not. And here's why. So again, to be a potential infinite, a collection must grow as time progresses. This is part of the definition of a potential infinite, right? A potential infinite is a collection that's always finite but ever increasing without bound. But, crucially, as time passes, the collection of future days does not grow. In other words, the number of days later than now never grows or increases as time passes. In fact, as time passes, days are, as it were, removed from the future, placed in the present, and then recede into the past. So it's just false that the collection of future days ever grows as time passes. But since growing as time passes is a necessary condition on being a potential infinite, it follows that the collection of future days is not a potential infinite. Here's the third argument. Suppose it's now true that the number of days, each of which will occur, is just, say, 10. Then, time will come to an end in 10 days, right? This is because we are supposing that there will only be 10 more days in reality at all, ever. So, in 10 days, time will come to an end. Hence, if time is endless, that is, if time doesn't come to an end, then it is false that the number of days, each of which will occur, is just 10. But 10, of course, here was just an arbitrary finite number, right? Let the number be 1.8 quadrillion. The same argument applies, right? If it is now true that the number of days, each of which will occur, is just 1.8 quadrillion, then time will come to an end in 1.8 quadrillion days. Hence, if time is endless, then it's false that the number of days, each of which will occur, is 1.8 quadrillion. What this proves is that if the future is endless, the number of days, each of which will occur, is not any finite number. It must instead be actually infinite, or Aleph null. For if it were a finite number, say n, then time will come to an end n days from now. But time, we are supposing, is endless, and so time doesn't come to an end n days from now. Hence, the number of days, each of which will occur, is not a finite number. It must instead be infinite. So let's put this formally. Letting n be an arbitrary finite number, we get the following. 1, if the number of days, each of which will occur, is n, then time comes to an end n days from now. 2, if time comes to an end n days from now, then time isn't endless. 3, so if time is endless, then the number of days, each of which will occur, is not n. But n, of course, was just an arbitrary finite number, so we can conclude to the generalized statement 4. If time is endless, then the number of days, each of which will occur, is not finite. From which it follows that 5, if time is endless, then the number of days, each of which will occur, is infinite. And that, of course, simply means that an endless future involves an actually infinite collection of days. And so we have an actual infinity on our hands, including all the alleged absurdities attending actually infinite collections. Here's the fourth argument, helping you see why an endless future is an actual infinite. If the future is endless, then the days later than today, that is, the days of which it is true that it will occur, can be put in one-to-one correspondence with the natural numbers. This is just undeniable. Simply map tomorrow with 1, the next day with 2, the next day with 3, the next day with 4, and so on for each natural number. There is no natural number n such that n fails to get mapped to a unique future day. This straightforwardly entails that the number of days later than today is Aleph null if the future is endless. And here's the argument put formally. 1, if the future is endless, then the days later than today, that is, the days that will occur, can be put in one-to-one correspondence with the natural numbers. 2, if the elements of a collection can be put in one-to-one correspondence with the natural numbers, then the number of elements in the collection is Aleph null, that is, actually infinite. So, if the future is endless, then the number of days later than today, that is, the days that will occur, is Aleph null, that is, actually infinite. Premise 1 is obviously true, right? I just specified a procedure that provides the relevant one-to-one mapping between natural numbers and days later than today. To deny premise 1 requires that there is some natural number n such that n fails to be mapped to a unique future day. But, of course, there is no such number as n. It couldn't be 20, since 20 is mapped to the future day 20 days from now. It couldn't be 200, since 200 is mapped to the future day 200 days from now. And it can't be 2 quadrillion, since that's mapped to the future day 2 quadrillion days from now. And so on. There simply can't be a natural number n that fails to get mapped to a unique future day. And this means that every natural number is paired with a unique future day. And this, of course, means that premise 1 is true. Premise 2, moreover, is true by definition. That's just the definition of Aleph null and an actually infinite collection. And finally, the conclusion entails that an endless future involves an actually infinite collection of days. Here's the fifth argument for why an endless future is an actual infinite. This argument employs mathematical induction. Now, mathematical induction, it's kind of unfortunately named because it's a deductive way of reasoning. It's not inductive in the sense in which scientists use induction, like this swan is white, that swan is white, every swan in our experience is white, so probably all swans are white. Now, of course, the Dutch explorer Willem de Vlaming disproved that in the 1600s when I think he went to Australia and discovered a black swan. But so that just shows us that the inference wasn't strictly speaking logically or deductively valid. By contrast, mathematical induction is actually logically valid. It's deductive. And it has the following structure, okay? So I'm just going to give you the abstract structure of this deductive form of reasoning. And by the way, P of n, that just means some predicate P. So a predicate is what you can say of a subject. So you can say of a subject that it is green. So is green is a predicate. So is 5 feet tall, is my brother, is red, and so on. Okay, so P of n means some predicate P is true of the natural number n. So the first premise in a mathematical induction is P of 1. That is called the base case, right? Because you're taking the first natural number and you're arguing that the relevant predicate P is true of that first natural number. And again, some definitions begin the natural numbers with 1, others with 0. We're just going to treat it as though it's 1. So the first premise is the base case, and you show that predicate P is true of the number 1. The second premise is that for any natural number n, if the predicate P is true of that natural number n, then the predicate P is also true of natural number n plus 1. That's what you can call the inductive hypothesis. And from those two, it deductively follows that for every natural number n, the predicate P is true of n. I mean, just think about it, right? If predicate P is true of 1, and you know that for any natural number n, if P of n holds, then P of n plus 1 holds, well, you know that P of 1 holds. So you can plug that in here, and you can show that P of 2 holds. And so now you know that P of 2 holds, then you can plug that into the antecedent here and show that P of 3 holds. And you know that P of 3 holds because you just concluded that, so you can plug that into here and then show that P of 4 holds, right? It's just repeated applications of modus ponens, right? So what this entails is that for every natural number n, predicate P is true of natural number n. So anyway, that's the general structure of mathematical induction. And mathematical induction can actually be used to easily prove that if the future is endless, then the number of days, each of which will occur, is Aleph null, in which case the collection of future days is an actual infinite. And here's how that proof goes. And again, why am I doing this? Because William Lane Craig, in that clip that we played, said that the number of days which will occur is not Aleph null. He said it's only potentially infinite. And this is just so obviously wrong that it triggers me. And so we have to go through these 5 different arguments. And thousands upon thousands have just parroted what Craig says there, and it bothers me. Okay, so we're going through these 5 different arguments. Okay, so again, mathematical induction can be used to easily prove that if the future is endless, then the number of days, each of which will occur, is Aleph null. And in that case, the collection of future days is an actual infinite. Here is how that proof goes. So suppose that the future is endless, and suppose Gabriel is going to count one natural number per day of the endless future, beginning with 1 and adding 1 each subsequent day. So Gabriel will count 1 tomorrow, 2 the next day, 3 the next day, 4 the day after that, and so on. With this in hand, we can now run the mathematical induction. So premise 1, it is true of natural number 1 that Gabriel will count 1. This is our base case. We're showing that some predicate P is true of the natural number 1, right? Here, P is the predicate, is a number that Gabriel will count. And then premise 2, we have our inductive hypothesis. For any natural number n, if Gabriel will count n, then Gabriel will also count n plus 1. And this is obviously true, right? If Gabriel eventually reaches natural number n, clearly Gabriel also eventually reaches n plus 1, since Gabriel will simply count n plus 1 the day after he counts n. And we're supposing that Gabriel never stops counting one number per day. Thus, if Gabriel eventually reaches n but fails to reach n plus 1, he would eventually stop counting, which contradicts our assumption that he never stops counting. Hence, it follows that if Gabriel will count n, then he will also count n plus 1. And of course, we've been speaking here in purely general terms, and so our conclusion here holds for each natural number n. And from those two, it deductively follows by mathematical induction that for every natural number n, Gabriel will count n. Premise 4, there are Aleph null many natural numbers. Everyone grants that. Premise 5, if 1, for every natural number n, Gabriel will count n. And 2, there are Aleph null many natural numbers. Then the number of natural numbers Gabriel will count is Aleph null, right? That's, of course, just trivial and obvious if you think about it. If it's true of every natural number that Gabriel will count that number, and there are infinitely many such numbers, well, then, of course, the number of numbers that Gabriel will count is Aleph null. 6, so it follows that the number of natural numbers Gabriel will count is Aleph null. 7, if the number of natural numbers Gabriel will count is Aleph null, then the collection of natural numbers Gabriel will count is actually infinite, right? This is true by definition. We have a collection here of natural numbers that Gabriel will count, and we already proved that the number of members in that collection is Aleph null, and hence, this collection is an actually infinite collection. So, from all that, it follows that the collection of natural numbers that Gabriel will count is actually infinite. Premise 9, there's a one-to-one correspondence between the collection of natural numbers Gabriel will count and the collection of future days within an endless future, right? This just follows from the original setup. For each natural number Gabriel will count, there's a unique future day on which Gabriel counts that number, and for each future day, there's a unique natural number Gabriel will count on that day. So this premise just follows from the original setup. Premise 10, if there's a one-to-one correspondence between two collections, then they have the same number of elements. This is true by definition. 11, so it follows that the collection of future days within the endless future is actually infinite. 12, if the collection of future days within the endless future is actually infinite, then an endless future is an actual infinite. That's just obvious. So an endless future is an actual infinite. As a result of these 5 arguments, I've shown that an endless future is an actual infinite rather than a potential infinite. Now, you might think I've gone overboard in this section in showing this, and you'd of course be right. But I get frustrated when I see boatloads of people repeatedly parrot the obviously false claim that an endless future is a potential infinite. I also get frustrated that this point has been repeatedly made to Craig since at least 2002, and yet 2 decades later, he still hasn't corrected himself. This is the paper where Wes Morstan originally made this point. But why does it matter, right? You might ask, okay, Joe, fine, an endless future is an actual infinite, but again, why does that matter? And so why does it matter if the future is an actual infinite? And so by the Hilbert's Hotel argument is impossible. Well, here's why it matters. For starters, several of the world's major religions, like Christianity and Islam, have traditionally promised an endless afterlife. The Hilbert's Hotel argument is therefore incompatible with such religions. This is why Craig has implicitly disproved Christianity. His Hilbert's Hotel argument, if successful, disproves Christianity's commitment to an endless future. So, Craig can join in with the slogan, by the way, Christianity is false, TM, and maybe we should buy him a hat with that on it. Now, one might propose that the afterlife is timeless rather than temporally endless to get around this. And so then it wouldn't really be an afterlife, right? Because that's a temporally after. But I mean, first, at least by my lights, this view is just implausible on its face. But second, and more fundamentally, at least in traditional Christianity, the afterlife involves the resurrection of the body. But plausibly, human bodies are essentially temporal. How, after all, could there be material brains, hands, arms, legs, and whatnot without them changing in any manner whatsoever? For if they changed, they wouldn't be timeless, right? Third, if there can be timeless material things, then even if the Kalam could prove that time has a beginning, and even if we grant that such a beginning needs a cause, the cause need not, in principle, be immaterial. This, in turn, undercuts a swift inference to God as the cause of time's beginning, an inference central to stage 2 of the Kalam. The fourth response to this point about an afterlife that's timeless rather than temporally endless is that the timeless afterlife view would seem to imply that we can become timeless or transition to a state of timelessness. But that doesn't seem to make any sense, right? Wouldn't our timeless state then be after our temporal state if we're kind of transitioning to it or becoming timeless? It just doesn't really make any sense, because then something timeless would be standing in a temporal relation, which is impossible. Yet if we never transition to timelessness, if we never become timeless at the end of our lives, say, well, then the timeless phases of our lives coexist with the temporal phases thereof. And that is strange, to say the least. It would require a portion of us to exist alongside God from timeless eternity. So again, it would require a portion of us to exist alongside God from timeless eternity, never truly coming into being. And that's actually going to get into difficulties with Genesis, because arguably the understanding of creation itself within Genesis in the Judeo-Christian tradition is that every created thing is such that it comes into being. Moreover, for my timeless phase to be a portion of one and the same person as my temporal phase, there would need to be some kind of continuity relation obtaining between them. But such a relation seems wholly mysterious. And we should also note that Craig at least explicitly rejects this timeless afterlife view.
It's up to God whether or not he exists timelessly and eternally or temporally and eternally.
So can he change his mind and go back?
Now that's a really profound question. Could God, say, annihilate the universe and annihilate the world and resume a state of timelessness? I don't think so. And the reason is that
he doesn't want to, or it's impossible?
That it would be impossible.
You think it's impossible for God
I think so, because I think that, given the nature of time, that if God were to annihilate the world, it would always make sense to say that God did, the world did exist. He did annihilate it. And he no longer exists with a world. So once time comes into being, that fact is always a temporal fact, even if God annihilates everything and goes back to a state of changelessness.
So that was a big decision he made.
Yeah.
So at least for Craig, on pain of inconsistency, he can't accept this timeless afterlife view. And his argument there that he provided wasn't ludicrous. It has some plausibility, at least. But even setting aside the religious implications of the impossibility of an endless future, there's another quite glaring problem. It just seems really plausible that the future could be endless, right? There's just nothing wrong with one event following another, following another, following another, following another, and so on without end. So then we have the following argument. If the Hilbert's Hotel argument succeeds, then the future couldn't be endless. Premise 2, but the future could be endless. Conclusion, so the Hilbert's Hotel argument fails. Now, we've already seen why premise 1 is true, and premise 2 is deeply plausible on its face. Furthermore, an endless future is entirely conceivable and imaginable, and if those provide at least some evidence for possibility, then we have still further reason to accept premise 2. So that concludes my 8th response to the Hilbert's Hotel argument, and so yes, I was right at the beginning. Craig has disproved Christianity, albeit implicitly. Assuming, of course, that his Hilbert's Hotel argument succeeds, which it doesn't, so... Oh my goodness, did I say the 8th response? That should be the 6th response. Gross. Okay, yeah, so that should be the 6th. Just ignore that. It says the 8th, but that's wrong. So on to response number 7, right? Infinite God problem. The 7th response that I'll consider is that God is, or at least involves, an actual infinite. We often hear apologists, theistic philosophers, and theologians describe God as infinite, right? God isn't some finite and limited being. Instead, God is infinite and unlimited. Moreover, God's omniscience seems to imply an actual infinity of divine beliefs. After all, God believes 1 + 1 = 2, he believes 1 + 2 = 3, he believes 1 + 3 = 4, and so on ad infinitum. So not only is God himself infinite, but God's existence seems to entail an actually infinite collection of divine beliefs. As Wes Morstan writes, since the number of mathematical truths, to say nothing of all the other eternal truths concerning properties and propositions and the like, is clearly infinite, it follows that an actual infinity is present in God's knowledge. So here's one way that Craig responds to the point about God's infinity.
Now, with respect to God, people will often ask this question, but isn't God infinite? And here I think it's very important to understand that the infinity of God is not a quantitative concept. God is not a mathematical quantity. So the infinity of God is not the infinity of a collection that is made up of an infinite number of definite and discrete parts. When theologians talk about God as infinite, it's more, as it were, a qualitative infinite, not a quantitative infinite. That is to say, God is omnipotent, omniscient, morally perfect, eternal, necessary, all-loving. And those aren't quantitative concepts. Indeed, in a sense, there isn't any separate attribute of God called infinity. It's kind of just an umbrella term for all of his superlative attributes. If you were to take away in your mind omniscience, omnipotence, eternity, necessity, holiness, there wouldn't be any attribute left over called infinity. That just is an umbrella term for all those superlatives, attributes that God possesses. So we shouldn't think of God's infinity as a quantitative concept. He doesn't involve an actually infinite number of definite and discrete pieces that go to make up his being.
So that does address the point about God's infinity, but it doesn't address the point that God's omniscience entails an actual infinity of divine beliefs. And on this latter point, philosophers Jacobus Erasmus and Anne Verhoef developed the following argument. Premise 1, if God is omniscient, then he knows an actually infinite number of things, such as propositions or truth values. Premise 2, if God knows an actually infinite number of things, such as propositions or truth values, then an actual infinite exists. Conclusion, thus, if God is omniscient, then an actual infinite exists. Now, one might object, and this is the first objection, one might object to the Erasmus-Verhoef argument by saying that propositions are abstract objects, and so don't have any causal power, whereas the absurdities in Hilbert's Hotel only attend to collections of concrete objects, that is, objects that do have causal power. Hence, there's a relevant difference between the actually infinite collections entailed by God's existence on the one hand, and the actual infinite collection of concretely realized past events on the other, which explains why the latter is impossible while the former isn't. But there are 3 problems with this objection. First, it's not at all clear why there would be an asymmetry between these kinds of actually infinite collections. You might think the reason is that collections of abstract objects aren't able to be shuffled or manipulated, whereas collections of concrete objects can. But the problem with this, of course, is that past events are also not able to be shuffled or manipulated, right? As we've seen, the past is done and over with. It's fixed. Second, the same quote-unquote absurdities actually do attend actually infinite collections of abstract objects. For instance, consider the set containing the natural numbers. Sets are abstract objects, as are natural numbers. Yet this whole set has the same number of elements as infinitely many of its proper parts. This was precisely the absurdity captured in Galileo's paradox. Moreover, we can consider 2 sets. One, the set of all natural numbers, and the other the set of all even numbers. There's a clear sense in which the second set, compared to the first, has infinitely many members removed. Specifically, compared to the first set, infinitely many odd numbers are missing. And yet the second set still has infinitely many members despite the comparative removal or absence of those infinitely many members. But now consider a third set containing just the first 3 natural numbers. Again, there's a clear sense in which this third set, compared to the first, has infinitely many members removed. Specifically, compared to the first set, all of the infinitely many numbers greater than 3 are missing. But in this case, the third set only has 3 members. And so, comparing the second set to the first, we saw that the removal or absence of infinitely many members resulted in infinitely many members. While comparing the third set to the first, the removal or absence of infinitely many members resulted in finitely many members. There is then a real sense in which identical quantities have been taken away from identical quantities yielding different results, which, you'll recall, was another central absurdity attending Hilbert's Hotel. What this shows us is that the same alleged absurdities attending actually infinite concrete collections also attend actually infinite abstract collections. And also, even if you don't think that members have truly been removed or taken away in the aforementioned scenarios, there are other scenarios involving abstracta that do explicitly involve taking away. For instance, we can consider the abstract relative complement function performed on sets containing natural numbers. In this case, the inputs, outputs, and the function itself are purely abstract, and yet the function is the same as the concretely realized function performed on the hotel guests in Hilbert's Hotel. So the third problem with the response that we considered earlier is that we can simply reformulate the Erasmus-Verhoef argument using concreta rather than abstracta, such as concretely existent divine beliefs. In particular, we can simply run the argument not in terms of the propositions God believes, but God's beliefs themselves. And there will clearly be infinitely many such beliefs if there are infinitely many such propositions. And that, of course, naturally leads to a second objection to the Erasmus-Verhoef argument. The objection is that God's knowledge has no propositional structure. God's knowledge, in other words, is non-propositional. God knows and believes everything by means of a single, simple, all-encompassing act of awareness. His omniscience doesn't then consist in having infinitely many distinct beliefs. Instead, he just has a single, simple conscious state by which he grasps everything. As Craig puts it in his book with the late atheist philosopher Quentin Smith, finite creatures break up the whole of what God knows into propositions which they know. But the fact that God's simple intuition can be broken down into a potentially infinite number of propositions does not entail that what God knows is an actually infinite number of propositions. And Craig puts the point similarly elsewhere. When we define omniscience as knowledge of only and all true propositions, we are expressing the extent of God's knowledge, not its mode. The mode of God's knowledge has traditionally been taken to be non-propositional in nature. God has a single undivided intuition of reality, which we finite knowers break up into individual bits of information called propositions. If God's knowledge is non-propositional in this manner, then God's omniscience won't involve an actually infinite number of distinct beliefs. And to avoid infinitely many abstract objects like propositions, numbers, and shapes that God's single act of knowledge encompasses, the defender of Hilbert's hotel argument will have to take something like a nominalist approach, denying the existence of abstract objects altogether. Now, I'll talk more about this second position the defender of the Hilbert's hotel argument is pushed to adopt later in this video. Suffice it to note for now that it's monumentally controversial, and it considerably increases the intellectual price tag of the Kalam. But what about the view that God's knowledge is non-propositional? Does that solve, we might ask, the problem of God's omniscience implying an actual infinite? Well, honestly, I'm not quite sure. On the one hand, it does seem to solve the problem, at least on its face, right? Once you deny the existence of abstract objects, and once you accept that God doesn't really have a collection of beliefs, but instead has a single all-encompassing act of awareness, then we don't seem to have on our hands any collection with infinitely many members. But on the other hand, I guess I still have reservations. After all, Craig seems to grant that we're still accurately describing God when we ascribe to him propositional beliefs. As Craig explicitly says, this does express the extent of God's knowledge, right? It simply doesn't express the mode of God's knowledge. That is the way in which, or means by which God knows things. But isn't that all we need to run the infinite God objection, right? Like, all we need is that we're correctly expressing something about God. Maybe not the mode of his knowledge, but at least its extent, right? Once we grant that we're accurately describing something about God, we can then count how many propositional beliefs are accurately ascribed to God. And the only sensible answer to that, it seems, is infinitely many. After all, the belief that 1 + 1 = 2 is accurately ascribed to God, as is the belief that 1 + 2 = 3, that 1 + 3 = 4, that 1 + 4 = 5, and so on ad infinitum. So it still seems that we have an actually infinite collection on our hands, namely the collection of propositional beliefs accurately ascribed to God and that accurately express the extent of God's knowledge. Another reservation for this approach is that if God's knowledge really isn't propositional, then it seems to become mysterious how we can accurately represent God's knowledge as beliefs toward propositions. Wouldn't this simply be a totally inaccurate representation of God if God's knowledge is thoroughly non-propositional and devoid of distinct beliefs? As Jacobus Erasmus writes, if God lacks propositional knowledge, then why think we can accurately represent God's knowledge using propositions? That God's knowledge can be represented as propositional knowledge is a good reason, I believe, to think God's knowledge is propositional, right? In the end, I think the infinite God objection is at least potentially a serious challenge for the Hilbert-Totel argument, and I'm going to leave it up to you to decide whether it ultimately succeeds. You can actually let me know in the comment section if you think the infinite God objection succeeds. So on to response number 8, and that is that the Hilbert-Totel argument actually fails to support the Kalam. Might sound surprising, but it really does fail to support the Kalam. So even if the Hilbert-Totel argument succeeded, indeed, even if it were an irrefutable proof, it wouldn't actually support the Kalam. Recall that Craig employs the Hilbert-Totel argument on behalf of the Kalam's second premise, which says that the universe began to exist. The idea is that the universe didn't begin to exist, that there's an infinite temporal regress of events stretching back into an infinite past. So, in order for the Hilbert-Totel argument to support the Kalam, we need to add a premise linking its conclusion to the truth of the Kalam's second premise. And so the full argument for premise 2 of the Kalam that we've been investigating in this video is going to have to be as follows. 1, an actual infinite cannot exist. 2, an infinite temporal regress of events is an actual infinite. 3, so there cannot be an infinite temporal regress of events. 4, if the universe didn't begin to exist, then there is an infinite temporal regress of events. And so 5, the universe began to exist. And indeed, it must have began to exist. You're also allowed to conclude that. So again, you need this fourth premise here, which links this conclusion here to the truth of the second premise of the Kalam, to the universe is actually beginning to exist. You need to say that if the universe didn't begin to exist, then there actually is an infinite temporal regress of events. And since there cannot be such an infinite temporal regress of events, it follows that the universe must have begun to exist. The problem, though, is that premise 4 is just false. More precisely, its consequent doesn't follow from its antecedent. From the fact that the universe didn't begin to exist, it doesn't follow that there's an infinite temporal regress of events. To explain why this is true, I'm going to show 5 ways in which it could, in principle, be true, both that the universe didn't begin to exist and there's no infinite temporal regress of events. Given that these are live options under which the antecedent of premise 4 is true, while its consequent is false, we can infer that the consequent doesn't actually follow from the antecedent. For starters, notice that under Craig's view, God didn't begin to exist, and yet by Craig's own lights, it doesn't follow that God has existed through an infinite temporal regress of events. Now, for Craig, since creation, God is temporal. Because time is past finite, according to subconclusion 3, it follows that God has a finite past. But again, God didn't begin to exist. And what this shows us is that by Craig's own lights, having a finite past is not sufficient for beginning to exist. Moreover, the fact that past finitude is insufficient for beginning to exist simply follows from the understanding of beginning to exist at play in the Kalam. It's actually a requirement on something's beginning to exist that the actual world includes no state in which it exists timelessly. This, for Craig, is why God didn't begin to exist, despite having a finite past, right? For Craig, the actual world does include a state in which God exists timelessly. Specifically, God exists timelessly without, or in the absence of creation, and he exists temporally with creation. What all this means is that God didn't truly come into being at the first moment of time. As Craig writes, God did not begin to exist at that point, he merely began to be temporal. But with this in mind, we can actually start to see ways in which the universe could very well not have begun to exist despite having a finite past, which again, we're assuming for the sake of argument here. Now, as I use the term here, the universe just refers to the collection of all physical things. So, are there ways for the collection of all physical things not to begin to exist despite having a finite past? Actually, yes. Oh, and by the way, this eighth response here that I'm going to be developing, this is actually one of the major problems for almost every single defense of the Kalam's second premise that I've ever seen. Most of those defenses of the second premise of the Kalam would only establish, at best, that time is past finite. But that doesn't show that the universe began to exist. It just doesn't. I mean, God's own past is past finite, right? God's own life is past finite, and yet God didn't begin to exist. And so being past finite doesn't entail beginning to exist. And so merely establishing that the universe is past finite, you don't thereby establish that the universe began to exist, and hence you don't thereby establish that it requires a cause. This is one of the major failings of people who think that they have a slam dunk case for the second premise of the Kalam, even if they've demonstrably proved that the past is finite. That doesn't show that the universe began to exist. So again, return to our question. Are there ways for the collection of all physical things not to begin to exist despite having a finite past? Well, actually, yes, there are. One way simply mirrors Craig's own view, right? The universe, or more carefully, some physical object or objects, could very well exist timelessly without metric time, but temporally with metric time. So, just like Craig's God, the universe, or some part of the universe, could very well have a timeless phase or portion of its life, in addition to a temporal phase or portion thereof. As philosopher of physics Daniel Linford notes,
when Craig talks about God's relationship to time, this notion that like God comes into time from being in a non-temporal state, in the papers where he argues that stuff, which is different than his Kalam papers, he uses the Hartle-Hawking model as a way to establish that it makes sense to say that something could be in a non-temporal state and enter into a temporal state. So in that context, he says that it's beginningless.
Now, as an aside, right, this is something that always triggers me. All you need is spontaneous, indeterministic causation to get a temporal effect from a timeless cause, by the way. But spontaneous, indeterministic causation obviously doesn't require free will. For instance, there are perfectly coherent, perfectly intelligible interpretations of quantum mechanics. I can't believe I wrote this. This was last night when I was writing this little portion. It was like 1 a.m. Okay. So for instance, there are perfectly coherent, perfectly intelligible interpretations of quantum mechanics that involve spontaneous, indeterministic, impersonal physical causation. But anyway, that's just a side note. So that's one way you could have the collection of all physical things not beginning to exist despite having a finite past. What about a second way? Well, a second way is for there to be a physical object that simply exists timelessly without having any temporal phases of its life. Perhaps there's some timeless quantum field or some timeless universal wave function. In fact, I myself have written on this latter proposal in one of my published pieces. I write, consider a temporal wave function monism. According to this view, there exists a fundamental physical non-spatiotemporal entity, the universal wave function. This is a perfectly respectable view that has seen a blossoming of interest in the philosophy of physics. I give a bunch of citations to Alyssa Ney, David Albert, Jill North, Julian Barber, Sean Carroll, and his I think it's Ashmeet Singh or something like that. Sorry, I forget Singh's first name. And note that wave function monists differ in how they understand the universal wave function, etc. But my point for this is that both physicists and philosophers have published on this burgeoning topic. It's actually not at all a fringe view. Indeed, it's a respectable view gaining quite a lot of steam, that there's a fundamental non-spatiotemporal physical object. And so there'd be a timeless physical thing. What paper is this? This is the title, by the way, if you're curious. You can find it on my website, josephschmidt.com, or you could just find it on my Phil Papers profile. And also, I cover this sort of view in much greater depth in my forthcoming book manuscript, Existential Inertia and Classical Theistic Proofs, published with Springer and co-authored with Daniel J. Linford. So we cover that in more detail in our forthcoming book. So that's the second way. It's for there to be a physical object that simply exists timelessly without having any temporal phase of its life. A third way for the universe to have a finite past but no beginning is if the universe or some physical object within the universe is fundamentally timeless but non-fundamentally temporal. Philosopher Daniel Linford explains this option really well, with James Fodor offering helpful commentary alongside.
I actually have a slight disagreement with many other folks about why the Hartle-Hawking model is beginningless. The way that I would put it is like this. Suppose there's an aspect of something, called this aspect A, that suffices for that thing's existence, but that would have existed even if time had not. So A is non-temporal. It suffices for the existence of whatever entity we're talking about. So long as I think as an entity is like that, then I think the entity is beginningless. And I think Craig agrees with this, because I think what Craig wants to say is that God would have existed even if time had not existed. And this is part of the explanation as to why God is beginningless. There's a family of cosmological models, quantum cosmologies, in which what's fundamental is the wave function of the universe. I think that on those models, the wave function is supposed to be more fundamental than time, in the same way that on Craig's theology, God is, well, I guess not quite the same way, but in an analogous way to the way in which on Craig's theology, God is supposed to be more fundamental than time. So that this is the real explanation, on my view, as to why this family of quantum cosmologies are beginningless, because they say that the physical world is not fundamentally temporal. And so long as the physical world is not fundamentally temporal, then since non-temporal things are beginningless, the physical world would be beginningless.
And by the way, as an addition there, to say that the physical world is not fundamentally timeless is not to say that time doesn't exist. You can still say that time perfectly well exists. Time would just be non-fundamental, and the fundamental physical things wouldn't exist temporally. The fundamental physical things would just exist non-temporally. That's perfectly compatible with there being non-fundamental physical things that exist temporally. Okay, so just no, we're not saying here that this view requires denying the existence of time altogether. Okay, but anyway, I also said there would be helpful commentary from James Fodor, and so that is what is up next.
This is a point that I've made before, and I mean others have made as well, that essentially what Craig claims is that God exists, sans the universe in a non-temporal way, but then when he created the universe, he came into being with time and came into being in a temporal form. So the question is, if that is sort of a thing that can happen, then why can that only happen with God? Why can't there be other types of entities, like some sort of quantum wave function or something, that exist non-temporally at some, well, one can't say some time, but exist non-temporally, and then also have a temporal sort of mode of existence, if we want to use that phrase. I think that that's open to the physicalist as well, that something like that happened. And I don't really think Craig has an in-principle objection against that. He just doesn't think it's as plausible.
I think it's quite important that there's a developing literature in philosophy of physics in which the view that people are working on is something, we might call it something like space-time reductionism or space-time emergentism, the view that that the physical world is more fundamental than space and time, and that space and time are somehow a less fundamental phenomena. And any view like that, the physical world itself is going to be beginningless, I think. I mean, I think that it's having a beginning requires something to be fundamentally temporal.
So anyway, that's a third way for the universe to have a finite past, but no beginning. Now, one might object to this sort of view, and some of these sorts of views, that there simply cannot be a timeless physical thing. But the problem is, why not? Sure, lots of the physical things in our experience are constantly changing and so exist within time. But why on earth should we conclude that absolutely every possible physical thing whatsoever must be temporal, including ones that we've never directly observed, and in some cases can't directly observe? That is a far too sweeping generalization, especially in light of the fact that there are respectable scientific and philosophical models on which there do exist timeless physical things. In fact, as Dr. Linford points out, Craig himself appeals to various physical models to establish the in-principle viability of his model of God's relation to time.
All of these arguments, whether the a priori arguments or the a posteriori arguments, they all fail for one reason. And that's that all that they actually establish, if they succeed, is in showing that the past is finite. After showing that the past is finite, Craig then must show that if it has a finite past, that the universe had a beginning.
Yeah.
Now, one of the things to notice is that Craig's God is supposed to be A, beginningless, and B, in time. And also notice that C, Craig thinks that time is finite to the past. That's what he takes these arguments to show in the first place. So therefore, Craig's God has only been in time for a finite period. So if it sufficed, if it really did suffice for showing that something had a beginning to just show that its past was finite, then Craig's God would have a beginning. But of course, Craig says that his God doesn't have a beginning. So now there are some places where Craig has tried to refine his conception of a beginning such that he's able to say that God has been in time only for a finite period, even though God is beginningless. Fine. But then what he doesn't do is to turn around to these arguments that are supposed to establish the past as finite and show that the universe is the sort of object that, because its past is finite, that it must have had a beginning. This is maybe even more problematic because in the places where Craig talks about God's relation to its time and tries to establish that it's conceivable that God could be in time for a finite period, even though God is beginningless, he relates God to various cosmological models, including models that he otherwise claims have a beginning in them. So, for instance, singular Big Bang models, he claims that in that context, he claims those models, in some sense, don't have a beginning because the singularity somehow is beginningless. So there's a weird kind of inconsistency there that Craig himself never resolves.
By the way, here's what Craig himself says with respect to such physical models. And notice that he's offering models on which the universe, understood as the collection of physical things, did not begin to exist despite having a finite past. So this is Craig himself speaking here, okay? So Craig writes, perhaps an analogy from physical time will be illuminating. In standard Big Bang cosmology, the initial cosmological singularity at which the universe, indeed spacetime itself, begins is not conceived to be an instant or any other part of time, but rather to constitute a boundary to time. Thus, it cannot be said technically to be earlier than the universe, and yet it is causally prior to the universe. It is clearly distinct from a terminal cosmological singularity, which represents the terminal boundary of a universe in gravitational self-collapse. Although the physical grounds for regarding such singularities as constituting boundaries to, rather than points of, spacetime are inapplicable to the notion of metaphysical time, nonetheless, they do serve as an illustrative analogy to the state of God's existing sans the universe. Perhaps we could say that the envisioned state is a boundary of time which is causally, but not temporally, prior to the origin of the universe. Or consider quantum gravitational models of the origin of the universe, such as the Hartle-Hawking or Vilenkin models. In such models, real spacetime originates in a region in which time is imaginary, that is, the time variable takes on imaginary values, and so is indistinguishable from space. The timeless forespace is causally prior to our real spacetime, and is, indeed, usually said to have existed prior to the Planck time, 10 to the negative 43 seconds after the initial singularity in the standard model. So Craig is here appealing to physical models on which the universe, despite being past finite, doesn't, strictly speaking, have a beginning. Because certain physical objects or physical states of affairs under such models are existing causally, according to Craig, causally, but not temporally prior to the universe. So anyway, that's a third way for the universe to have a finite past but no beginning. A fourth way in which the universe could fail to begin to exist without there being an infinite temporal regress of events is if the universe, or some physical object or state, exists in a non-metric or undifferentiated or amorphous time prior to the beginning of metric time. This is a view that lots of really respectable philosophers like Richard Swinburne and Alan Paget and Ryan Mullins have defended concerning God's relationship to the beginning of time. But it can equally be developed along lines friendly to non-theists, right? And so the articles that I'm talking about that you can see, so for Richard Swinburne, you can see his article God and Time in Reasoned Faith, which Eleanor Stump edited. It's published in 1993 with Cornell University Press. Alan Paget, he has a book, God, Eternity, and the Nature of Time, published with Palgrave Macmillan in 1992. And then Ryan Mullins, the book that I'm talking about is his upcoming book, From Divine Time Maker to Divine Watchmaker. So again, these are views that lots of philosophers have defended concerning God's relationship to the beginning of time, but they can equally be developed along lines friendly to non-theists. Because the time prior to the beginning of metric time is undifferentiated, it doesn't have a beginning. There's no sense in which that time dynamically comes into being at some definite point. It also isn't metricated. That is, there's no fact of the matter about how long it is. It's devoid of measurable intervals. To be sure, right, Craig has other objections to this view of non-metric or undifferentiated time. But first, philosophers like Ryan Mullins have responded to such objections. And second, his objections don't actually imply, which is relevant for present purposes, his objections don't actually imply that such a state has a beginning. One of his central objections is just that, well, this kind of non-metric, undifferentiated time prior to the beginning of the universe seems just indistinguishable from a kind of timeless state causally prior to, but not temporally prior to the universe. And of course, Ryan Mullins responds to it. Ryan Mullins talks about how no, it's actually distinguishable from it because it stands in a temporal relation with the subsequent metricated time, right? It stands in an earlier than relation to it, and so on. So anyway, we don't have to get into that debate here. So that's a fourth way. A fifth and final way in which the universe could fail to begin to exist without there being an infinite temporal regress of events is developed in philosopher Stephen Purrier's article, Finitism and the Beginning of the Universe. Here's how it goes. Craig and other defenders of the Hilbert's Hotel argument more generally reject the possibility of actually infinite collections. But a problem presents itself here. Consider the fact that things move from one point in space to another. In so doing, the moving object passes through an actual infinity of intervening points. Similarly, whenever some period of time elapses, an actual infinite has been traversed, namely the actual infinity of instants that make up that period of time. Space and time, it seems, entail the existence of actually infinite collections of points and instants. The way that Craig responds to this objection is by holding that there's really only a potential infinity of points in any spatial region, and a potential infinity of instants in any temporal period. What makes such a position possible, writes Puryear, is the view that space and time and other continuous wholes are not composed of their parts, but are instead prior to their parts. Consider the example of a line. It may strike us as natural to think of this line as composed of an infinity of points or infinitesimal line segments set end to end, in much the way that a house is composed of bricks. On the alternative view, however, the line is a whole which exists prior to any parts we may discern within it. Rather than being composed of these parts, the line is, in itself, a single whole from which parts are formed when a mind conceives of it as divided. Thus, given that finite minds can only mentally divide a whole a finite number of times, it follows that no continuous whole ever has more than a finite number of parts. Here's how Craig himself articulates his view. If one thinks of a geometrical line as logically prior to any points which one may care to specify on it, rather than as a construction built up out of points, then one's ability to specify certain points, like the halfway point along a certain distance, does not imply that such points actually exist independently of our specification of them. By contrast, if we think of the line as logically prior to any points designated on it, then it is not an ordered aggregate of points, nor actually infinitely divided. Time as duration is then logically prior to the potentially infinite divisions we make of it. Craig thus maintains that space and time are divided into parts only insofar as we specify such parts. In themselves, and apart from human minds, space and time are not composed of smaller units. Thus, on Craig's view, space is in itself just one thing, that is, an indefinitely extended simple region. As it is conceived by us, space would indeed be divided into a number of smaller regions. But these divisions would exist only in our thought, not objectively, or a partere, verbally, on the side of the thing itself. The same would be true of time. Time, on this view, is explanatorily prior to any temporal parts we might conceive within it. Time divides into parts, such as points or subintervals, only insofar as we divide it in thought. Let's call this sort of view time priority. Puryear argues that time priority entails a similar thesis that we can call event priority. According to event priority, events are prior to any sub-events we might conceive within them. In other words, whole events do not divide into parts except insofar as we divide them in thought. Here's how time priority entails event priority. Events, as changes, take time to occur, and they typically have both a beginning and end in time. For instance, take the event of me lifting my arm, which begins at time t1 and ends at time t2. In order for this event to be a distinct event in its own right, distinct from, say, what was happening with my arm prior to t1 and after t2, the period from t1 to t2 needs to be a distinct period of time in its own right. But given the thesis of time priority, there is no such distinct period of time apart from our conceptual activity. As it is in itself, time is just one long duration without any temporal parts, not a sequence of intervals that add up to a longer one. So the aforementioned event is a distinct event in its own only if the period during which it occurs is similarly a distinct event in its own. And since the latter depends on our conceptual activity, per the thesis of time priority, it follows that the former similarly depends on our conceptual activity. Hence, time priority entails event priority. In fact, just as Craig embraces time priority to avoid an actual infinity of temporal parts within any finite temporal period, he must likewise embrace event priority to avoid the same problem. As Puryear writes, if we take events to be changes, then they are just as infinitely divisible as time. For any such event, no matter how short, can always be divided into two sub-events at any point we like. But if events are infinitely divisible and they are also composed of their temporal parts, then they must be not only potentially divisible to infinity, but actually infinitely divided. In other words, if the parts are prior to the whole and the whole exists, then the parts must exist. But if the existence of the whole presupposes the existence of the parts and the parts go to infinity, then there must actually be an infinity of parts. For the finitist, however, this presents a serious problem, for it would entail that any event is in fact an actually infinite sequence of sub-events, so that the occurrence of the event involves the sequential occurrence of all the sub-events. So, not only does time priority entail event priority, but Craig seems committed to event priority for precisely the same reason he commits to time priority. But here's the problem, right? Here is the payoff. If event priority is true, then premise 4 of the extended Hilbert's Hotel argument is false, right? Recall that premise 4 of the extended Hilbert's Hotel argument. Premise 4 is that if the universe didn't begin to exist, then there is an infinite temporal regress of events. Now, this is simply wrong if event priority is true. For if events do not divide into parts, except insofar as we divide them in thought, writes Puryear, then we must admit that just as time is in itself merely one long interval, the history of the universe up to the present is in itself just one long event. To the extent that it forms a sequence of events, it does so only insofar as we divide it into parts. And since we can only divide it a finite number of times, it forms at most only a finite sequence. So even if the universe didn't begin to exist, and even if the past is infinitely long, under event priority, it is simply false that there's an infinite temporal regress of events. There can only be a regress of finitely many events, and per time priority, only finitely many temporal intervals. And again, this is because under event priority, apart from our mental divisions, there's only one long event that is the history of the universe. Similarly, under time priority, apart from our mental divisions, there's only one long temporal interval that comprises the history of time. Thus, under event priority, there's no infinite regress of events, even if the past is infinitely long. And similarly, under time priority, there's no infinite regress of temporal durations or intervals, even if the past is infinitely long. So, if event priority is true, premise 4 is simply false. Now, you might be thinking at this juncture, okay, fine, maybe Craig embraces time priority and so is committed to event priority, and with it, a denial of premise 4. But I don't need to embrace Craig's view, or at least what may seem to be Craig's view. You can see note 6 underneath response number 8 in my reference document for more on Craig's view here. You might think, I don't need to respond to this argument by embracing Craig's view of the structure of time. In particular, I don't need to say that divisions of time exist only insofar as we mentally conceive and divide them. Instead, I can adopt other views of time structure, consistent with denying the possibility of actual infinities. For instance, maybe I can simply adopt what's called a discrete view of time, on which time is naturally broken up into smallest units. Now, in one sense, that's correct, right? You certainly can embrace other views concerning the structure of time. But in another sense, this response just misses the point. Remember, we're in a context in which the proponent of the Kalam is offering a positive argument for the universe's beginning. The burden is therefore on them to positively justify their premises. As we've seen, though, event priority is incompatible with premise 4. So, in order to justify premise 4, proponents of the Kalam need to give positive reasons for thinking that event priority is false. The onus isn't on me to prove that it's true, right? I'm simply pointing out that there are coherent views on which premise 4 comes out false, and that in order to justify premise 4, the proponent of the Kalam therefore needs to rule out these views. If the proponent fails to rule them out, then they simply haven't adequately made their case for premise 4. As long as event priority remains a viable option, the proponent of the Kalam has not yet established the crucial premise that a beginningless past would consist in an infinite sequence of events, rather than one simple event that we simply divide in thought. So the proponent of the Kalam needs to do much more than simply adopt an alternative view concerning the structure of time. They also need to show that event priority and time priority aren't even viable options. For, again, if they are viable, premise 4 is insufficiently justified. And if premise 4 is insufficiently justified, then even if the Hilbert's Hotel argument succeeds, it doesn't support premise 2 of the Kalam. So anyway, that concludes my 8th objection to the Hilbert's Hotel argument. It was pretty heavy at times, but if you can understand and appreciate it, it's actually super duper rewarding. So here's a quick summary so you can have a bird's eye view of this 8th objection. In short, even if the original Hilbert's Hotel argument succeeds, it doesn't actually support the second premise of the Kalam, which states that the universe began to exist. It would only support the Kalam's second premise if an infinite temporal regress followed from a denial that the universe began to exist. But that's just false. An infinite temporal regress doesn't follow from a denial that the universe began to exist. In principle, it could be the case that the universe didn't begin to exist, and yet there's no infinite temporal regress of events. I articulated 5 models that illustrate this. On the first model, the universe, or some physical object, exists timelessly without metric time, but temporally with metric time. On the second model, some physical object or objects simply exist timelessly, without having any temporal phase whatsoever. On the third model, the universe, or some object within the universe, is fundamentally timeless, but non-fundamentally temporal. On the fourth model, the universe, or some physical object or state of affairs, exists in a non-metric or undifferentiated time, temporally prior to the beginning of metric time. And finally, on the fifth model, both time and events, as wholes, are prior to their parts, and their parts only exist insofar as we mentally divide them. With this model, the past can be infinitely long without there being an infinite regress of events or temporal intervals. Hence, on this model, the universe can be beginningless without there being an infinite regress of events or temporal intervals. And note that this is the only model of the 5 that actually involves an infinitely long past. It's just an infinitely long past that doesn't involve an actually infinite collection of discrete members, right? It doesn't involve an actually infinite collection of discrete events or discrete time intervals, given time priority and event priority that we covered earlier. So the general lesson here is that the Hilbert's hotel argument fails to support the Kalam's second premise.
Failure! Failure! You're still a failure! Failure! I can smell the failure! 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 Stephen! Use failure! Failure! This is called failure! My son's a failure! Failure! Failures! Failure! 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 You're all failures! Failure! You're still a failure! A failure! 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 Failures! My son's a failure! Failure! Fail! Always call you failure! Failure!
All right, so my 9th and final response, one which I won't explore in requisite depth, but nevertheless want to put on your radar because it's generally overlooked in popular discussions, is that there are actually positive reasons to think that actual infinites are possible. Now, just a note on the collective force of these, even if none of these are compelling, indeed, even if none of them are very plausible, so long as you give their premises a non-zero probability, their evidential effect can accumulate to quite drastically lower your confidence in the impossibility of actual infinites. That's just a note. So again, I'm just going to be very brief here, but my point is just that there are boatloads of arguments for the possibility of actual infinites that are totally overlooked in these sorts of discussions. You have arguments concerning abstract objects. There are so many different arguments for the existence of abstract objects. And if there are abstract objects like numbers and sets and propositions and universals and so on, then there are obviously going to be infinitely many of them, right? The number 1, the number 2, the number 3, the number 4, and so on. The proposition that 1 plus 1 equals 2, the proposition that 1 plus 2 equals 3, the proposition that 1 plus 2 equals 4, and so on. The proposition that Joe is not identical to the number 1, the proposition that Joe is not identical to the number 2, the proposition that Joe is not identical to the number 3, and so on. The universal being 1 foot to the left of, the universal being 1.1 foot to the left of, the universal being 1.111 foot to the universal being 1.111 feet to the left of, and so on. So literally any argument for the existence of these sorts of abstract objects, for mathematical objects, for propositions, for universals, and so on, is ipso facto going to be an argument for the possibility of actually infinite collections. And there are boatloads of these sorts of arguments. You have abstract reference. So like 2 is my favorite number. It actually turns out to be incredibly difficult to reparse that sentence in a way that doesn't ontologically commit you to the existence of the number 2. Because we seem to be referring to an abstract object. For that sentence to be true, our words would have to be refer, and the only plausible candidate for the reference there is an abstract object. You have indispensability arguments, right? Like mathematics, mathematical truths, mathematical theories, mathematical theorems. These sorts of things are utterly indispensable to our best scientific theories, and arguably that gives us good reason to think that there are such things as these mathematical objects. Moreover, there are various mathematical truths that seem obviously true, like 1 plus 1 equals 2. But if truths have to correspond with reality, right, per the correspondence theory, which is one of the dominant views in philosophy today with respect to what truth is, the only plausible candidate portion or bit of reality to which that sentence corresponds would be the mathematical realm, right? Would be the number 1, the number 2, the plus function, the equality relation, and so on. Arguments from propositions. Many philosophers argue that you need propositions in order to even make sense of communication. When we communicate with one another, we have one and the same shared content in mind. Otherwise, communication would be impossible. And so there would have to be one and the same shared communicative content between us, not just my private individual thoughts and your private individual thoughts and so on. We need something that's shared in between us and that we're both latching onto. And that's going to be some non-linguistic or extra-linguistic item, a proposition. Similarly, propositions make sense of translation. Propositional content is precisely what's shared between translations, like snow is white and Schnee ist weiß. Right? Those are different sentences. And so there's a distinction between these, but there's something obvious that they have in common. They have a shared meaning, and the meaning of that corresponds to a proposition. You have arguments from that clauses and ontological commitment and so on. With respect to universals, people appeal to universals to explain objective resemblances among things, like multiple different things are blue, and so people argue that you need the universal blueness in order to be able to explain how they objectively resemble one another. In turn, it explains the character of ordinary objects. It gives us truth makers for various predications concerning them. You have arguments from truth supervenes on being and so on. So there are boatloads of arguments concerning abstracta that would justify us in thinking that actual infinites are not only possible, but actual. We have arguments from physical quantities. So some of our best physical theories treat various quantities as continuous. For example, temperature, pressure, time, space, energy content, and so on. Continuous quantities, in turn, entail actually infinite collections, as granted by Craig and others. And moreover, you might add quite plausibly that the fact that our best physical theories commit to P gives us good reason to believe that P. All these together gives us good reason to think not only that actual infinite collections are possible, but indeed actual. Still further, you have modal arguments for the possibility of actually infinite collections. Their general structure is that you use a modal tool as applied to some actually infinite collection. You then add a premise that this modal tool is a defeasible guide to possibility, and so we have a defeasible reason to think that actual infinites are possible. What are some examples of modal tools that you could use? Oh, well, you could say certain actually infinite collections are perfectly conceivable, perfectly imaginable. You can use modalized induction. You can use modal uniformity. For a principle that Josh Rasmussen has defended, the principle is roughly that if x differs merely in quantity from y, and we know that y is possible, that gives us reason to think that x is possible. You can argue in turn that some infinite collections differ merely in quantity from finite collections, and those finite collections we know are possible, and so we have reason to think, defeasible reason of course, but still reason to think that the infinite collections are likewise possible. Rasmussen has defended this in various papers, most notably his, I think it's a 2014 or 2013 article in the Australasian Journal of Philosophy. He's also defended it in his book Necessary Existence, co-authored with Alexander Proust, published with Oxford University Press in 2018, and so on. And there are still other arguments. There are boatloads of other ones. You can see, for instance, my video Causal Finitism in the Kalam with Dr. Alex Malpass and Dr. Wes Morstan for various reasons for thinking an infinite past is at least possible. I use a bunch of different modal epistemological tools to argue for that. There are also reasons for thinking that there is no such thing as agent causation. For example, some philosophers say that agent causation renders it inexplicable when the relevant causing occurs, since the agent or substance as such is always present. If that's right, then plausibly only events are causes. But per the Kalam's causal principle, events require causes. But if events require causes, and if, as many think is true, there are such things as events, and if only events can serve as causes, then an infinite causal regress of events is inevitable, right? The regress of events causing one another is either linear or circular. If it's circular, then we get self-causation, which is absurd, and which the Kalam needs to grant is absurd in order for the Kalam to succeed. And if the regress of events causing one another is linear, then it's either finite or infinite. But it can't be finite, since then there would be an uncaused event in violation of the Kalam's causal principle. And so you're just inevitably led into an infinite causal regress of events, which in turn constitutes an actually infinite collection. Again, even if you don't find this convincing or even plausible, right? I'm not here like defending this argument as successful. I'm not sold on there being no such thing as agent causation. My sole point here is that even if you don't find this convincing or even plausible, if it has a non-zero probability of succeeding, right, which it surely does, right? You're surely not certain that it fails, then it should correspondingly lower your confidence in the impossibility of actual infinites. And again, the more such independent arguments there are, the lower your confidence should be. And there are many, many more arguments besides. Steve and I will be covering some of these in our Kalam series, which I highly recommend you check out. And again, more generally, check out my Kalam playlist. On to the conclusion and summary. So I've pulled no punches in this video. My goal is to make this video the best online resource in existence on the Hilbert's Hotel argument, and of course to make it freely available to a public audience. I kid you not in this. I have genuinely poured dozens upon dozens of hours into this video alone. If you enjoyed it, maybe you can share it on social media, especially if you have friends, relatives, or acquaintances who think the Hilbert's Hotel argument succeeds. And come on, if you're watching this video, you probably hang around in circles, maybe on Facebook, maybe on Twitter, maybe on Reddit and other sorts of places. You probably hang out around circles that are apologetic circles or philosophy of religion circles. So share this with those sorts of circles. And more generally, if you enjoy the channel, be sure to subscribe. And if you're feeling especially grateful for my work, consider supporting me on Patreon. Any amount helps. I do all this work essentially for free, right? I'm not getting paid to do any of this other than your generous patronage. And it's dozens of hours of work put into editing, recording, researching, writing scripts, reading philosophy papers, and really just pouring myself into these sorts of things. All in the service of others, all in the service of you guys who are watching this, who are benefiting from it, and all in the service of truth and the majesty of reason. And as a reminder, right, to those of you who are signing up on Patreon, I'm doing a giveaway of those Hilbert's Hotel stickers. So any of you who sign up for $3 or more per month, the first 5 of you are going to be getting a free sticker together with a personal note thanking you. And it's a Hilbert's Hotel sticker. So yeah, go see the beginning of the video for more on that giveaway. But anyway, let's recap. So I first began the video by defining key notions like set, cardinality, actual and potential infinites, and metaphysical impossibility, after which I articulated the Hilbert's Hotel argument. According to this argument, actual infinites are impossible, and since an infinite temporal regress of events is an actual infinite, it follows that an infinite temporal regress of events is impossible. The alleged absurdities of Hilbert's Hotel were used in support of the claim that actual infinites are impossible. I then developed 9 responses to the Hilbert's Hotel argument. First, lots of the alleged absurdities of Hilbert's Hotel rest on subtle ambiguities, and once the relevant disambiguations are made, the absurdities just disappear. Second, the alleged contradiction Craig obtains from transfinite subtraction isn't at all contradictory, since Craig's argument equivocates between the relative complements of sets and the differences between their cardinalities. Moreover, there are non-Cantorian systems of transfinite arithmetic in which transfinite subtraction is allowed and engenders no contradictions whatsoever. Third, with respect to Craig's appeal to Galileo's paradox, Craig gives us no reason whatsoever to accept the universal and unqualified truth of Euclid's principle, as opposed to a version of Euclid's principle as restricted to finite sets. Moreover, even upon making this restriction, we can still preserve the intuition that whole sets are greater than their proper parts, so long as we get clear on what greater means. Fourth, many people don't even find the relevant properties of actual infinites unintuitive, and even among those that do, that doesn't support the impossibility of actual infinites. In fact, it's not at all clear why we should expect our intuitions about the properties of infinite sets to be a good guide to truth. Fifth, the central absurdities afflicting Hilbert's Hotel crucially depend on the ability to manipulate, shift, and move guests around. But this is crucially disanalogous to an infinite past, since the past can't be manipulated, shifted, or moved around. To infer the impossibility of the latter from the impossibility of Hilbert's Hotel is thus a hasty generalization. Sixth, the Hilbert's Hotel argument succumbs to a symmetrical argument showing that the future cannot be endless. The reason is that an endless future, like a beginningless past, is a collection containing infinitely many elements that can be put in one-to-one correspondence with the natural numbers. An endless future, in other words, is an actual infinite, not a potential infinite. Not only is this a super implausible entailment of the Hilbert's Hotel argument, but it also entails that, by the way, Christianity is false. Seventh, God's existence seems to entail actually infinite collections. Given God's omniscience, there seem to be infinitely many distinct divine beliefs. If this is right, then the Hilbert's Hotel argument entails that God is impossible, and hence that atheism is true. Eighth, even if the Hilbert's Hotel argument succeeds, it doesn't actually support the Kalam. It would only support the Kalam's second premise if a premise is added to the effect of, if the universe didn't begin to exist, then there's an infinite temporal regress of events. But as I explained, this premise is just false. Ninth, there are actually positive reasons for thinking there are, or at least there can be, actual infinites. Now, again, to conclude this video, please consider supporting me on Patreon. Please smash that like button, subscribe, turn on that little bell for notifications. Unfortunately, YouTube doesn't want to give you guys the videos that you want to see. So in order to be notified when my videos come out, please click that little bell to get notifications on my content. There's also an option of making a one-time donation. So if you don't want to have the kind of monthly commitment for a Patreon, you can do a one-time donation. Think of it like me putting out my hat at the end of a performance. Thank you guys all for even considering that. Also, if you're interested, check out my Kalam playlist, right? I go over so much about the Kalam in there. I talk about the causal principle, the arguments for the causal principle. I talk about other arguments for the finitude of the past, like the successive addition argument. I talk about Hilbert's Hotel and other videos in there with Alex Malpass and so on. I talk about causal finitism. I talk about Benedetti paradoxes, Grim Reapers, endless futures, all different sorts of things in there. I even talk about some of my published work on the Kalam and causal finitism. Also, check out the reference document that I'm going to be putting in the description of this video. So if you're watching this video, you probably hang out in circles, as I've said, where these sorts of things are discussed, and this video could help them see treasures of truth that they may otherwise have missed. Anyway, please stop using Hilbert's Hotel, because it fails drastically. So that's my final message. Anyway, what better way to end is there than, I'm Joe Schmid, this is The Majesty of Reason, and peace out.